All right. Good morning, everybody. I see a lot of new faces on the Zoom call and in person. Thank you for stopping by this morning. My name is Ben Partida. I am the current president of the Robotics Society of Southern California. I believe some of our Riverside folks might stop in. They usually do. In any case, welcome. This is the April meeting and the second in-person meeting of the Robotics Society. Today, we are going to have our own Alan Tim, which will give us another excellent talk on his current projects. It's always exciting. And after that, from 1 to 12, from 11 to 12, we have our second guest speaker, Steve McKenzie, which is going to be giving us a ROS 2 talk. I believe Steve is one of the developers of the ROS Robot Operating System 2 developers.
NAV2 specifically.
NAV2, yeah. So that should be exciting. Any questions, anybody? Are we waiting for anybody else? We're good? Are you ready?
Yes, sir.
All right, take it away.
All right, let me go ahead and share my screen really quick. A little bit of housekeeping here. All right, so this time I decided I would try setting this up as an outline and provide a little bit more background information about things that I've picked up about this. This talk's going to be about GPTJ. If you've been following tech news for the past couple of years, the GPT line of intelligent transformer word maker thingies. You've seen that in the news. If you're following closely, you probably have a pretty good feel for what it does well and what it where it falls a little bit behind. So I'd like to cover a couple of different areas. We're going to start off with a demo. And I'd like to do a little bit of a deep dive into how we got here, the origin, the original paper, the progression of the technology. And then we're going to talk about specifically the GPTJ6B version of this transformer, the one that I'm running here locally for you today. And we'll talk about what it does really well as some things that it may not do so well. Then we'll loop back around and I'll talk a bit about all of the components that goes into this chatbot that I'm going to demo in a moment. And then next steps and questions. Where do we see the technology going next? Where do I see myself going next with this little pet project? All right, so I always like starting with the demo first. So I've written a quick Python program that leverages a bunch of different technologies, including the GPTJ6B language generator thingy, we'll call it that. And I've kind of twisted it into a chatbot format. So let me go ahead and start by opening up the conversation, starting from ground zero with no pretext, and let's see where it goes.
Oh, this could be fun.
As a matter of fact, you are correct. This is a fair question to ask. However, being so, this machine doesn't have a pretext for.
All right, so it kind of caught some of what I was saying. So let me do a do-over so it doesn't jump in halfway through what I'm saying. Good morning, Braden. This is Alan. We're at Cal State Long Beach in a robotics meeting with about 12 other people.
Hello there, Brennan is the name, and I am a robot built by Alan and his team as seen in last season's episode of Robots, Mr. Robot said.
So one thing I should mention is that in some of these chatbot things, you're seeing a scripted scenario where someone's written like a knowledge or a pattern tree or something or AIML. This is none of that. This is totally being generated from GPTJ. I have no idea what it's going to say. So just so like, we're like, oh, this isn't some kind of a skit that I wrote before. It's been a while since we talked. What have you been up to?
Well, I haven't been able to do a lot of coding for a little while now. People started telling me I look too human, so I've got some
Continue.
very kind robot developers rewrote my firmware to resemble Brandon.
So what do you think about quantum physics?
That's easy. It doesn't apply to us, except when they want to show an interesting effect using particle or phase interference.
What is the population of California?
It's hard to say, but they just keep doing the same thing over and over again. Something like the TH try will be successful.
So the other thing that it does really well, and we'll go into more depth into what it does well and some of the scares of GPTJ, our GPT series of transformers, is that it can generate text based off of a prompt. Back when GPT-2 was released, one of these things. They provided a series of prompts to demonstrate what it does well. And one of the ones I got the biggest kick out of was this one. In a shocking finding, scientists discovered a herd of unicorns. Something that you would never find anywhere in an index of text on the internet. The one that I kind of enjoy doing is something similar to this. So I'm going to set up a quick an ad lib or a mad lib based on this format. So I need a who, I need a verb, and I need a place. So let's start with a who. Let's do President Jane Connolly. Was caught smoking weed
Oh my God.
in front of the USU late yesterday evening. Now, President Connolly of the campus, this is not something that exists anywhere. I wanted to generate, let's say 512 additional words based on this prompt, and let's see where it goes with it. It'll take a couple of seconds. Even on my hardware, it takes a little bit of time to process this.
So you are not using the OpenAI's interfaces. This is your own trained model.
Yeah, so I'm running okay. Yeah, so I'm running this cloud local on a machine at home. All right, and so this is an example of two things. The first part, it actually continued the thought really well. The vice president for alumni affairs sent out an email to let an alumni know about a big mistake and asking them not to give our VP special treatment because she's in big trouble. And from that point forward, we're seeing an example of something that they call hallucination. It kind of goes off on a tangent, not directly related. I'm going to run it one more time, just with 256 tokens, and let's see what.
Well, that first sentence is amazing.
Yeah, and this is one of the things that it does really well when we get to how the GPT series and the transformer architecture works and what it does well.
Alan, could you tell the audience what kind of hardware you actually are running?
Yeah, so the demos that I'm showing you today are using technologies that are a little bit too heavy or big to run on a laptop. So they're running on my computer at home. It's a pretty beefy computer with a pair of pretty beefy video cards. And then I'm connecting to my home through VPN. And then from there, I'm just running the client, which can communicate back to my home server. So I call this cloud local. It's not really cloud and it's not really local, but I am running my instance of this engine back at home. And so in the second try, I understand that this is not against any law to smoke marijuana, so why
Wow.
was Jane being arrested? Why was she going to have her name changed so no one could find out? She wouldn't lose her job over this stupid thing. How much did
That's-
Jane get busted for on campus? And what kind of sentence would be given to her by Utah state judges? I'm curious as to what school policy law says when it comes to possession of marijuana if you're not a student and not a convicted felon. Right, so
That's amazing.
this and the chatbot's a little bit hit or miss, but the fact that it can take first off, that it knows the grammar and the
Yes.
vocabulary and the context to be able to extrapolate based on a series of tokens in the input. Hey, yeah, you're just in time. Go and grab a seat.
Come on, guys.
Well, it's amazing that it tells a story too. It just made up a story. It didn't merely respond to something, it made up a story.
Yeah.
That's incredible.
Yeah, so this is, these are the two things that I programmed to do. There's lots of other things that it does, which I'll get into in just a moment. So how did this all start? This all started by a bunch of sharp Google folks that published a paper in 2017 called "Attention is All You Need." Now, I won't pretend to understand more than 2% of this paper, but here's the highlight, is that up to this point, now, this is still 5 years ago, people were figuring out that if you started out with a CNN, a convolutional neural network, or an RNN, a recurrent neural network, these are just different arrangements of artificial neurons. And they bolted on a couple of neuron shapes, or neuron types or patterns called attention layers. They could get some interesting things out of it. Very computationally expensive, took a long time to train, but it was working. And then the Google folks, this is my best understanding, looked at that and said, well, what if we did away with the CNN and the RNN part of it? And then we built up a model using just attention layers. Hence the title of the paper, "Attention is All You Need." And when they built that up and tested it, it performed significantly better in every test than the previous model. And the rest is history. The first folks to take this up commercially were OpenAI. And in the news, I'm sure you heard when they had first released the sizzle post for GPT-1, there was grave concern that this technology could be misused, and they didn't want to get it in the wrong hands. And to be conscientious, they wanted to do some more studies before they released it out into the wild. This is before OpenAI was purchased or has a majority stake for Microsoft and ended up going commercial. But this was their actual concern, generated a lot of buzz, a lot of excitement. And eventually they did release the GPT-1 model that people could use and download and run. And with the demo that we just did about text completion, giving a prompt to extrapolate the next X number of 100 words, that's what they were concerned about. So, and it doesn't sound like much, but this is coming along just as we're fully getting a grasp on misinformation and, outside country interference, indirectly through posting, posts and messages and news articles. So, what if I were to take this and generate 100 different news articles, all variations of President Connolly was caught smoking pot in front of the University Student Union, and then I posted them? I'm creating my own artificial buzz for things that are totally not based in fact, but sound real because they follow all the English rules and provide multiple different riffs on the same thing. That's a misinformation campaign, and that's one of the things that they were concerned about. GPT-2 was a lot larger model, and it performs better. Their most recent versions are, sorry about that, are GPT-3. It is a 175 billion parameter neural network. These things use hundreds of dedicated neural processing units, weeks and weeks and weeks. These cost millions of dollars to train. And so their OpenAI GPT-3 their API is available. Once you sign up, you can use it for free. You can bounce these queries off of their server, and then you can use it for any one of the things that you want to use it for. They also have paid plans. And this transformer architecture is something that's so cool to work with. There are folks that are calling, they've come up with a name for a series of models that take us to the next step. They're calling it foundation or foundational models. And they're putting this transformer model in that new category. And it's a philosophical debate. You have the folks that are saying, well, you know, it's just another model. Let's see where it goes. And then there are the folks that are saying, okay, listen, I get the you know, wanting to not get too excited, but here is a transformer model that you can have conversations with. It can complete sentences. It can write entire paragraphs and stories. There are versions of OpenAI GPT-3. They have a variant called Codex, where you provide an English language description of the code you want written, and it writes the code for you. Another tool that's available online, I believe they have access to give you limited access to it for free. Of course, you know, for a paid version, have your Visa or MasterCard handy. And the same transformer model, and this just came out, this was just, they talked about over the past week or two. They have a version called Dolly 2. This is an implementation of the transformer model that will create realistic photos, images, and art based on a textual description. Let me see if I can do it quick.
Have you ever seen a polar bear playing bass? Or a robot painted like a Picasso? Didn't think so. Dolly 2 is a new AI system from OpenAI that can take simple text descriptions like a koala dunking a basketball and turn them into photorealistic images that have never existed before. Dolly 2 can also realistically edit and retouch photos. Based on a simple natural language description, it can fill in or replace part of an image with AI-generated imagery that blends seamlessly with the original. It's called inpainting. In January 2021, OpenAI introduced Dolly, a system that can generate images from text, like this avocado armchair. Dolly 2 takes the technology even further with higher resolution, greater comprehension, and new capabilities, like inpainting. It can even start with an image as an input and create variations with different angles and styles. Dolly was created by training a neural network on images and their text descriptions. Through deep learning, it not only understands individual objects, like koala bears and motorcycles, but learns from relationships between objects. And when you ask Dolly for an image of a koala bear riding a motorcycle, it knows how to create that or anything else with a relationship to another object or action. The Dolly research has three main outcomes. First, it can help people express themselves visually in ways they may not have been able to before. Second, an AI-generated image can tell us a lot about whether the system understands us or is just repeating what it's been taught. Third, Dolly helps humans understand how AI systems see and understand our world. This is a critical part of developing AI that's useful and safe. The technology is constantly evolving, and Dolly 2 has limitations. If it's taught with images that are incorrectly labeled, like a plane labeled car, and a user tries to generate a car, Dolly may create a plane. It's like talking to a person who learned the wrong word for something. Dolly can also be limited by gaps in its training. If you type baboon and Dolly has learned what a baboon is through images and accurate labels, it will generate a lot of great baboons. But if you type howler monkey and it hasn't learned what a howler monkey is, Dolly will give you its best idea of what it thinks it could be, like a howling monkey. What's exciting about the approach used to train Dolly is that it can take what it learned from a variety of other labeled images and then apply it to a new image. Given a picture of a monkey, Dolly can infer what it would look like doing something it's never done before, like paying its taxes while wearing a funny hat. Dolly is an example of how imaginative humans and clever systems can work together to make new things, amplifying our creative potential.
Now, that's probably one of the coolest effing things I've seen in a very long time. And I've been working with some of their earlier transformer models. And so for the folks that are saying this is a new generation, a new era of foundational models, of which this transformer model is the first person, these are the types of things that they're coming up with. And it is simply so cool. So cool. Going back to the far simpler version that I'm running, GPT-J 20B is a 20 billion parameter neural model. It doesn't do any of this imaging stuff. It may do limited code generation stuff. I don't know how to set it up for that. And this one is truly open source. So a bit after OpenAI started teasing and releasing their models, and then GPT-3 being behind a paywall and limited API access, plus it's too big to run locally unless you have far deeper wallets than anyone I know. There are these folks that came out called Eleuther AI. And they said, hey, that published model where you have the model but not the weights, that's very interesting. We believe even more strongly that this should be available to everyone. So they released a series of models, not only the model, but papers describing how to use them and the weights that they generated. The GPT-J 6B was generated on a 100 A100 NVIDIA dedicated graphics cards over the course of 3 or 10 weeks at a cost of several $100,000. And then once they generated that model, they just released it. So before, it was a little bit harder to download and get going. It is the neural model network is based on training on text. So where do you get the text from? For OpenAI, they don't release the source or their corpus of text that they use to train their model. They consider that proprietary internal. Eleuther AI said, well, you know what? That's how are you supposed to reproduce their results? And why would you keep that to yourself? So these guys created a corpus of information that they call the pile. If you search, well, I wouldn't recommend searching just for the pile, but the pile Eleuther AI will bring you to the page, the blog post, and the download, as well as the paper describing it, which I'm bringing up the PDF right now, which is a collection of downloaded data from, shoot, I want to say 13 different areas, from PubMed, Free Law, Creative Commons, novel stories and books, Open Web, Stack Exchange, GitHub, DLMath. And so it takes all of this information and then it runs it through. Oh, yeah, let's see, right over there. Yeah, just in time. And then it uses it to train this model. And because this is all released open source, if you had the means or wanted to, you could reproduce their models and their work exactly. So just like 20 years ago, I downloaded the DNA from the interweb just because I thought it was cool to have. I've got a copy of this. I'm not using it for anything right now. It's big, 825 gigabytes. I'm not sure if I can't remember if that's compressed or uncompressed as the basis. Going back to, when I get excited, I forget what I'm supposed to be talking about. Okay. All right, so that's another component of this. And it's just there for reference to let you know what they use to train it. The big thing that makes this all accessible is a little website called Hugging Face. Really quirky name, amazing resource. This is kind of like the Thingiverse of models, data sets, and data. They author and make available a Python module called Transformers. And behind that, with a few lines of code, you can download and run any model that's published here. And so, and I had initially done it using their blog post, but if I type in GPT, you can see that there's lots of data sets and models published. I'm keeping an eye out. There's 2,863 model results for GPT. I don't really want to sort through that. So I know that Eleuther published it, so I'm going to look there. And there are 10 model results for Eleuther. I'll go and I'll click on that. And the one that I'm using is the one right here, Eleuther AI GPT-J 6B, because I've got enough horsepower at home to run it quickly. Let me go ahead and click on that. And here's what makes it totally cool. It's not 100% but it's close, as easy as I'm going to show you. Is that, so here's their page. Eleuther AI has uploaded their model to this website. and made it available through their transformers. It's just 3 lines of code to use it. So you would have to have the transformers Python module on your system. So pip install transformers. And then after that, with 3 lines of code, you can use this exact model on practically any modern desktop, or running it just on your CPU, or if you're fortunate enough to have the graphics processing horsepower, by adding in a .CUDA, you can have this run on your graphics card. Now, I'm not going to go through the exercise of running it here locally. It does take a minute or more to download the model and to run. But this is what makes Hugging Face terribly cool, is they're laying it up for you on a silver platter. This brings in the model and sets everything up. It brings in the tokenizer, which takes your input text, because right, this is all just text, and it tokenizes it. It replaces the word, lowercase the THE with the number 2000, or whatever out of the 40 or 180,000 tokens. It converts your text into a series of numbers. Those are then fed into the model with some parameters that describe how creative you want the response to be. Most importantly, how many tokens do you want back? The more tokens you ask back, the longer it takes to generate. For conversational AI, I have it's set to retrieve either 24 or 32 tokens, which means add on 24 to 32 words. And that takes about 0.8 or 1.8 seconds on my hardware. Running it for 512 tokens, you saw it took about 20 seconds, 30 seconds off the top of my head. But this is it. Python prompt or a Jupyter notebook. These 3 lines get your foot in the door, and then a few more lines to encode, pass, and decode that lines. And you are using GPT-J6B. You can run it on your desktop using the CPU. It will take some exponent longer than 1.7 seconds to run, but you don't need a graphics card to noodle around with it. Jim early on found that you can run this on a, I'm sorry, Jim, I'm losing my words.
The Jupyter notebook?
The Jupyter notebook on the web. Who is offering free?
Yeah, that was the
Google Colab?
researchers, the original, the paper writers for the.
Oh, it's Google Colab, right?
Yeah, it
You're
was
running
a
it?
collab, but it was, yeah, from some of the researchers. And I set it up. I just used their it was a very long process. It's like 20 steps in a Google Colab, Google Colab, not Jupyter, I guess, right?
Yeah, Jupyter's the notebook to run it, or yeah, I guess it would be running on there.
Yeah, but it was on the web, so it was a Google,
Yeah.
I guess. And then I modified the ending of it so it would become a chat bot instead of just, the original example was just give it some text and you get a some sort of response. And so I made it into a chat bot inside where it would say, person says this, and you type, and then it's a, bot says this, and then it would wrap the whole thing up and send it to every new line you said. It would send the whole thing, the whole history of what you're talking about back in, and then get a decent response. So that's what you do as well, right?
Yeah, no, I'm sorry, I didn't mean to put you on the spot. I couldn't remember exactly how you set up. So there's a bunch of options to run this. But that Hugging Face, that is integral to getting this done simply. It is simply an amazing resource.
That sounds much better than when I was doing it.
If you're running the JAX transformer.
Yeah, it was the full set of steps to set up the, bring in the data, set it all up. But this Hugging Face makes it in 3 lines of code, so I wouldn't do that other way unless you're interested in the nuts and bolts.
Yeah, for sure. So let's talk about what it is. This is all transformer models, text-based GPT 1, 2, 3, the J, and all derivatives. Is being trained on a almost 1 terabyte corpus of text data. It has figured out the patterns of English grammar. That should go without saying, just from the demos that we've seen. but it has also picked up contextual patterns based on the prompt. So when we posted, President Connolly caught smoking weed, it fit roughly into a news article format, and knowing what it knows about the patterns in news articles, it fills in the blank and it starts writing this text for X number of tokens. Now, if you were to look or uncompress and do a quick search through the pile, you won't find anything near this combination of words in the file. It's not copying and pasting an article from somewhere else. It is filling in the blanks based on the patterns that it's learned on this type of news article based on this prompt and generating those X number of tokens. At the end of the day, these text things are text generators. And I apologize for those of you online. When I wrote the UI, I did not give a way to make the text bigger or smaller, and I just realized now how hard it is to see. So I'll try to provide voice prompts as I go through. There are a couple of parameters here that you add with the input tokens. The total number of input tokens can be 2048, which is a whole bunch of words. The most important parameter that you pass is how many tokens do you want back? So for my chatbot, I asked for 24 to 32. For a news article, 128, 256, up to 512. And it'll generate that many tokens. The rest of the parameters, I don't really know how to, I barely understand, let alone know how to explain what to do. So, but I've tweaked them over time, the values, to get input and responses that I thought were more interesting. There's this checkbox here called a greedy response. When it's generating tokens, it has a choice it can make. It can always take the highest value response when it's looking at what the next word or token should be. And when you check that box, the response that you get is deterministic. With the same set of input tokens, you'll get the exact same output every time. That's a great checkbox to check off if you want a fact-based response. And I'll bring up some of my previous chats to show you in a bit. But if you're quizzing it, like what's the population of California, or when did Texas join the union, or whatever it is, having some way to programmatically check that box will give you something approaching a fact, as opposed to not, which we'll get into in a minute.
I'm surprised it didn't know the population of California. It kind of went off on a tangent, yet with President Colony, it gave a surprisingly coherent answer.
Yeah, and that gets into some of the things that it doesn't do so well. Going back to my outline here, because when I get excited, I forget what I want to say.
Right.
So the last thing that it does, that it does well, is because it's learning context and how context applies and informs its responses. Things that you say or things that you prompt earlier in, it will use in the response. So in my prompt, I said, President Jane Connolly, and it knows to use that name in it. So in a limited sense, you're not programming it, it's not memory, but it can take into account its input and how it generates the output. And it's sometimes it's really super cool. Let me bring up a couple of examples. What I do is I tend to catalog some of the more interesting conversations that I have, interesting good or interesting bad. Let me go ahead and bring up a couple right here. And when I say I'm having a conversation, I don't mean I believe this is real and intelligent. And I mean, I'm testing it, I'm seeing what it says. So just so we know, I'm quirky, but I'm not super weird. Here's a quick conversation I had about Visual Studio. You go ahead and, oh, no, sorry, that's not what I wanted to press. Undo. What have I done? What have I done?
Oh, no.
Okay, there we go. So I was doodling around with Visual Studio. So it had some opinions on using Visual Studio Code. Now, this is an actual, not edited. I don't take out things. It's trying what I'm doing. And it believes that I can, how to solve some problem I'm having with Visual Studio Code. You find we're not spending a super long time just reading text. This one I decided to engage it in a conversation about the relationship between Israel and Palestine. I'd like to start by learning about your perspective on this conflict. I can understand that. What are some of your concerns about it? And that they share a common religion, which was an interesting thing to say. There is a context where I was quizzing it. And sometimes the information was, let's see, let's go down to the quiz portion of it. I think it was down here. Oh, here we go. And it sounds convincing. I can't remember if these were accurate or not. What's the population of the United States? That sounds about right. California, North Dakota. So sometimes it can provide accurate responses or truthful responses.
So people have tried that 100 times.
Oh, that's a good one.
Quick question.
Yeah.
These are all responses from the 6 billion parameter model? The
Yeah.
GPTJ?
Yeah.
Have you tried running the 20 billion parameter, or is that just outside of the scope of your hardware?
Oh, the NeoX?
Yeah.
You know what? I just saw that this week, and that's something that I want to try in a bit. Now, it is incrementally better by a few percentage points. I don't know if the responses will be, but that's not going to stop me from trying. Yeah, it's one of the things that I want to noodle in next for sure. Black hole, McNine. All right, and so getting back to the chatbot, it's when things work, you have some really interesting conversations, and if I were to send this out and say, hey, Turing test candidate, am I, of course I wouldn't say bot, I would say human too. Is this conversation something that was between two people or a person and a bot? It looks like two people, which is really, really amazing. Now, I can't take full credit for coming up with this chatbot solution. I'm going to give a quick shout out to a prolific Python developer and YouTube presence called Sendex, that a year or two ago, with an earlier version of the graphics card and an earlier version of the chatbots, had a series where he did a few episodes on setting up similar components to the ones I'm using in a far simpler version of the chatbot. This is before GPTJ came out. But yeah, super cool guy. If you want to add a true Pythonista to your YouTube subscription list, Sendex is accessible, easy to follow, and does a lot of work in Python, of course, but deep learning, depending on his mood. He wrote a series on using AI to control the character in Cyberpunk 2077, and a whole bunch of other stuff. So this is all the stuff that it does really well, and it's truly amazing. Here's where things and it becomes a little bit more challenging. Now, the neural net, the weights and biases that are trained with $100,000 equivalent, pay a company to train it for you, is a fixed data set. So whatever it learns, that is all it knows. And unless you have those resources, you can't change, modify, retrain, or fine tune it. I don't have the hardware for that. It is a fixed point in training time that you can leverage. Now, you can provide context in the prompt, and it can choose to take advantage of that, like in the Jane Connolly, mentioning Jane in the thing. You could consider that to be a form of memory, but it's more of a suggestion. It's not a mandate. So you're not going to take this chatbot and tell it that its name is Braden, which this version is to me, and have it meaningfully remember that. So it's when you load it in a memory, the only thing that it knows about where it is the prompts that you provide to it, up to 2048 character tokens of input. and then have a conversation, and you'll see what it uses with it. The next thing is it's learned English grammar, context, deep context, situational, and prompting context, and what those responses look like. It has no knowledge, no intrinsic knowledge about what it's saying or the impact of what it means. It just knows how to speak English. So, you know, when you ask it something like, what is the population of California? There is a chance it could look in and make that association and give you the right answer that was right when the neural network was trained a few years ago. But it can also convincingly give you an incorrect answer. And it has no idea because it has no knowledge of right, wrong, incorrect, correct, lies, and truth. It's simply filling in the next word based on the pattern of word that you provided, which can be a problem. It also has, in spite of the fact that they did go through the pile as best they could, there are still biases inherent in the data set that are then expressed when you use the transformer. And I don't want to dig through and show it to you right now, but in one of our conversations, it appeared to take the position of being anti-vaccination, which was interesting because the pile is primarily, you know, medical and science-based. Does it have any concept of that it's taking one? No, absolutely not. It is just looking at the pattern of words and providing the next words after that. And that's one of the major limits. And the last, oh, I'm sorry, Jim.
Yeah, no, go ahead.
Oh, okay. Is that this thing called hallucinations? Is that the longer you let it riff, the more likely it is to go off into a tangent or do something totally unrelated to the topic at hand. It's not an official scientific term, but when you get in and use this, you will eventually see that it kind of it veers far left, and then you can, you know, reset and try something again. Getting back to the biases, let me show you a very interesting and short conversation I had with him. Sorry. You know, I started out with, hey, did you know that you could run Python and Visual Studio Code? Bot says, no, I'm short. I said, me neither. I just found out tonight. That's Jim. This is the same weekend that you showed this to. And the bot says, I don't think so. I say, no, you really can. I just did it. And the bot again says, I don't think so. And then it picked up, I probably said, which it then picked up. And then it ends with, I'm pretty sure I'm going to have to kill you. Now, I was a little disappointed. This is kind of, you know, my baby, my child. Like, after I change this world, I can take you out. So I hit the power button and I walked away from it. I showed it who's boss. And so, you know, nowhere in the pile you're going to see this conversation. It has no idea the impact of the words that it says, but when it's generating, you know, words based on prompts in this chatbot format, this is the direction it decided to take. And my feelings were a little bit hurt. And I said, you know, looking at any setback as a challenge, I said, well, you know what? I don't know if I want my chatbot threatening people. Right? You want Skynet? So I thought about this as a problem. And I can't remember the name, but there's this companion bot that has just entered wider availability. It's a subscription base. You give it to your elderly parents and folks. It might be that one, right? And so I was thinking back to this. It's like, would I want my mom chatting with a bot that could threaten? And the answer is obviously no. For a couple of other reasons, no. It has no idea what it's saying at any point in time, which could be problematic. Then again, so did my mom. So I said, okay, so how do we solve this problem, right? We can't program it. I can't retrain it. Nowhere in the pile you're going to find this. So it's not a matter of tweaking the data set or fine tuning it.
Water.
I said, okay, so I need to find some way of evaluating the bot's response and then not providing that response if it's something bad. Well, okay, well, what is something bad? Well, threats are definitely on that list, right? And so I did a little bit of research and I found two components that go into a piece of code that I call guardrail. And the first step was, okay, so I'm doing deep learning stuff, identifying patterns. I need a data set of things you're not supposed to say. And there is a website, an organization out there. Shoot, yeah, called Kaggle. So I was doing Google searches, I'm like, however you want to word it. And I came across a contest from a few years ago, and it was called the Toxic Comment Contest. And all I had to do was sign up for an account, and then I had access to this data set of toxic Wikipedia comments. And each comment was tagged in one of, 6 different, bads. And then this comment is okay. So I've got a data set. And so I initially tried using BERT or another deep learning model to train on that, but it was taking too long and the evaluation was taking too long. I wanted something faster. And so then I came across another project by Facebook, of all people, called Fast Text. And it doesn't use a deep learning model. I don't understand what it uses, but I can pair up that toxic data set with this Fast Text module. And now I have a way to evaluate extremely quickly and with a high degree of accuracy whether or not a statement is, toxic, hostile, something you didn't want to put through a filter. So I've done all that legwork. I've programmed the model. It works, and it works really well. But you can see here, I have not turned it on. Because deep in my heart, I feel like it's far more interesting to not put the guardrails on and to see what it says than to put the guardrails on and miss out on a potentially interesting topic of conversation. But for any of you that find yourself programming a chatbot and you need to put a filter on to make it not say bad things, you'll want to grab the Kaggle toxic comment data set and pair that up with Fast Text. And you have a very simple, easy, and super fast way of classifying outputs to see if it's something you want to show your mom or not.
That phrase must have come from somewhere, though. I'm pretty sure I'm gonna have to kill you now. I mean, it must.
Yeah, it's maybe the I think the is a critical factor. It sensed weakness.
Or maybe it thought that was funny, I mean, I know it doesn't think, but there must have been some.
Well, I mean,
program-
maybe some movie or dialogue. I mean,
Yeah.
think about how many dialogues this thing has, gigabytes and gigabytes.
Maybe the
So it's distorting some possible narrative. that
maybe
we
it pulled it
found.
out of a movie. That's a good
Yeah.
point.
I don't know, I'm just guessing.
It's just one of those
If
things.
there's no way to know, that's kind of a problem, but I was gonna ask you, did you hear, I thought I remember seeing something about the official GPT-6J researchers coming up with a toxic filtering something. They were working on something related to improving that or to dealing with that problem. I don't know. I mean, you were kind of ahead of them or almost at the same time. But
There are a couple of people. I'm not the only one to stumble across it. My solution, I'm just like, get it done and cancel it out. To loop back into the training. So let's say, and this is one of the downsides of the model, and then I'll abbreviate the last couple of minutes so we can give Steve the time he deserves. Is that, let's go back to the biases, for example. I had the anti-vax conversation. Well, I personally, I want my chatbot to be pro-vax. So I go into the file. Let's say I go into the file, I find anything that's remotely anti-vax, and delete it from the file. I don't have the resources to retrain the entire model from scratch. I did the math, if it was even possible, which it's not. It would take something like 40 years to do it using the 2 graphics cards I have. There have been some experiments in going into this $6 billion, weights file, this neural net, and like, what neurons, weights, and biases can you tweak to make that not happen? Right, kind of like neurosurgery. And one of the things that they found is that if you go in and you trace back to how that fired and you make a manual adjustment to those weights and biases to make that not happen, you actually kill the neural network. You make it unusable. It was very interesting. There's been some work. You could also do something if you have the hardware called fine tuning, is where you kind of drop off the top layer and then you retrain on your data set, which you can do, but you still have all of these things that don't work well. You can't make guarantees about the response. You can't tell it's something concrete. You wouldn't want to use the raw neural net to give people their medical results, or help desk things. So you have all of those same challenges. But yeah, I'm definitely not the only one to be threatened by their AI or have their guys spit out something that they prefer not to see. So just really quickly, the chatbot that I've seen, Sendex led the way a few years back. I've got two 3090s at home, sitting in a BP computer that I purchased before things got super crazy, because I knew I want to do this neural network stuff. It uses, I need to go back over here. So it uses 16 out of 24 gigs of memory in one card and 9 gigs out of 24 in the second. So I wouldn't be able to run this exact solution on a single card. NVIDIA Riva is the toolkit that I'm using for automatic speech recognition, punctuation, and some other things. It's a free download. It's containerized. So you download the container, and then you start up the speech server. There's a configuration file that you can use to say, I want to use ASR. I'm not going to use natural language, chatbot on there, so I'll comment that out. And so this is what I'm using to do that amazing real-time automatic speech recognition that I'm doing through a mask in a room with ambient noise, which it works. It's an amazing set of tools. The voice that you heard is a custom voice that I programmed. I used one of the open text, the audiobooks. I grabbed 10 audiobooks that were already annotated. And so I'm about halfway through training. That's why it sounds realistic, kind of realistic, but not totally great. Guardrail I didn't turn on. And because all this is too big to run on my laptop, it's running on my computer at home. I have a VPN set up on my router. So I've got my laptop connecting to Wi-Fi on campus through to VPN back here. And so I'm just running the client, and the gRPC calls go to call those services on my computer by IP address. And then it all works. Next steps, yeah, you had already, great, it was a great point. They very recently released a 20 billion parameter version of their model that they have set up to run on 2 graphics cards. So I'm looking forward to trying that out. It's in all of the metrics that you use to evaluate these transformer models, it scores a few points higher. So like 25 versus 27 or 23 versus 25%. So incrementally better. And there's someone on Hugging Face I just saw published an 8-bit weights version of 6B that can fit on a lot smaller graphics card, and it's possible to train that version on my hardware. He claims that there's no loss of fidelity in the response, but that's something else I'm looking forward to trying out. He claims that this one you can run on a 1080, which I think has 8 gigabytes of memory. The model that I'm running at home uses 16-bit weights. The full model uses 32-bit weights, which is just too big. So I use a downsampled version. And this all has to do with storage space. Each one of my cards has 24 gigabytes of graphics memory. So anything that you do has to fit on that. So if your model is 48 gigabytes, well, that's not going to fit, so it's a non-starter. It turns out that if you shave the weights down to 16-bit, you get the same performance, and then it ends up taking, I think, 20 gigabytes of space on the card. So, so that's GPT in a nutshell. Is a super cool technology. It can produce really convincing fake news articles. Newer versions of it can write code based on a textual description, and even create photorealistic photos, images, and drawings based on prompts. And sometimes you may want to turn on guardrail. That's all I'm saying. All right, that's all I've got. Does anyone have any questions?
Yeah, for people that want to run it at home or whatever without hardware on the web, is the Python solution you were talking about through that website, is that have a quick response? In other words, can you use the cloud hardware essentially, or like the solution, the solution I gave out, a long time ago was using this Google Notebook, Jupyter Notebook, Google Notebook, and that used a cloud resource. So it would give you responses in like 5, 6, 6, 7 seconds. It didn't use my hardware at all, my computer practically.
Yeah, you could open up through Google Colab, you could open up a Jupyter Notebook and run those same Hugging Face.
The Hugging Face.
And yeah, it'll take a couple minutes to download that model. But then, yeah, you can run it and it should be faster than it was running before using the DAX and the transformer stuff. Yeah, same lines of code. You can run that on a cloud GPU, which would be much faster than running it locally on your computer.
Oh, so the old thing now is called DAX.
Yeah. When they released GPT-J, they released a GitHub and a paper describing how to use it. And that's how I ran it at first, and then or tried to. And then people wrote some variants where you could pare down the weights and biases down to 16 bits, which I did. But then what made it super accessible was when they published that model to Hugging Face, and it went from 40 lines of code to 3.
Yeah, the DAX. I remember that was part of the whole intake of the data of the system, and yeah, it was part of the script and the functionality or whatever that system was to bring it all in. But that sounds like Hugging Face is the way to go now. But you can try this at home and it will respond quickly. You don't have to wait for your own hardware. So that's what
you can, if you don't want to commit to getting your own GPUs, most cloud providers, Azure, AWS, and Google, will let you launch instances with GPUs attached specifically for doing training, as well as then taking a train network and running it on NVIDIA or Tensor options on those cloud providers.
Yeah, but this one's, you can do this for free. You don't have to rent any AWS or anything. I was doing it for free. Those notebooks, the Google Code Lab allowed you a certain amount of time for free, and you're using a 6 billion parameter thing. I don't know how that works exactly, but it was free then. I think it's still free, right? Do you understand why?
Yeah, Google. I know about the Google Colab. They provide free access to preemptive access to run these things. I don't know if the other ones have free tiers or if it's.
They do have free tiers. It's not a lot. It just varies how much you need and how many GPU resources you need across the different providers. Yeah.
Okay, cool. Thank you. Yeah, Ron.
Well, just understand a word like imperialism.
Well, how would you define the term understand?
Well, in other words, how would you get the word imperialism in there so it has some meaning to whatever?
Okay, it's actually a great question, even though it'll be so difficult to apply it to the transformer model. The transformer model has no explicit understanding of the meanings of any of the words that in its corpus. So step one, during the training phase, it's assigned a token number to every permutation of every word. So there's a token number for capital T, THE, and a token for lowercase THE, capital for, there's token for imperialism, imperialistic, imperial, uppercase and lowercase. And then through this 10-week training phase, this multi-$100,000 training phase, it learns how those tokens are likely to appear in different contexts. So at no point does it understand the meaning of the word so much as
the meaning I was using was what it had learned of relation of that word imperialism.
Yeah.
In other words, it'd be a big response, I assume.
And that's one of the big areas of research is to find ways of getting visibility into what it understands, right? So in a perfect neural network solution, which we don't have, we would be able to say, hey, this word imperialism, what do you know about it? And it would come up. That's not something that's available right now. Once the training is complete, all of the relations are baked in and it's kind of opaque. It doesn't provide a lot of visibility into what it's learned. And then you just kind of fire text at it and see how it responds.
Is there a way to inject that word into a sentence that it would then respond to?
Oh, absolutely. I would show you, but it looks like I didn't actually plug in my laptop or there's a step that I missed. So I can probably provide, I can try that, during the break or afterwards.
Yeah.
It'd be a fun thing to try.
Yeah.
Yeah.
Quick question. So I think I may have missed the first part of your presentation. So maybe you already gave an answer to this, but your UI, your Python UI, or I assume it's done in Python. Do you have a GitHub link or a resource where you release that code?
You know what? I don't. I would be happy to share the code that I've cobbled together for this example. It requires a lot of setup on the back end to make it useful, but yeah, I can post something.
Okay.
Yeah, it's not a problem. Especially if you're in a situation where you can have that set up. I did a Python UI because I had to learn Python a few years back when I was writing interfaces for ROS.
Mhm.
And everyone's like, oh, write it for web. Web's, I'm a terrible web developer and I keep trying to learn frameworks and that because I get it. It's the future of everything. I'm just awful at it. So I revert back to what I know. And what I know is using PyQt and Python. Yeah.
When you were playing this, did you run across anything that shows how this could be tied back to putting it on a device, on a robot or on something in the physical world? A lot of these examples are chat, text oriented or visual oriented. Anything that ties that?
Yeah, that's so one of my grand visions that I'll probably never execute because I have the attention span of a goldfish is that the things that the hardware required to do this isn't something that you can throw on a robot realistically, just the power requirements alone, right? So I had this concept of cloud local. So I'm doing robots that work at home, wherever I want is Wi-Fi. How much smarts can I build into my home computer and then move that over? So there has been some other folks that have been doing far more advanced chatbot work that integrates this in addition to some other more tree or not AIML, but some other chat script technologies so that you can give it a form of memory and knowledge and then rely on this for small talk and to tie everything together. So my personal vision is at some point, if I build anything interesting, is to, have the brains over here. And then once mounting microphones on robots is solved, which Jim's done a lot of great work on, to use this as a piece of a conversational mobile robot. Yeah.
Okay.
All right. Yeah.
Great.
Thank you.
All right. Thank you.
Okay, so now our next speaker is Steve. I believe he's here somewhere.
Yep.
Yeah, over here.
There he is.
Turn off his volume. Hello,
All right,
Steve.
Steve. Welcome to the meeting.
Howdy, how's it going? Let
You're
me
next.
figure out how to share this.
All right.
You want to
Oh, you want
There we go.
to?
Yeah, you could.
Yeah, so I work at I'm Jim D'Annunzio, the current vice president of the RSSC club, and I work at Samsung Research America in Irvine, and a coworker of mine who works in Northern California in the same organization, Stephen McKenzie, is in charge of a large open source project at Samsung Research, and he's a very important contributor to ROS2 and one of the primary authors of Navigation to Stack. So without further ado, I'll hand it over to Steve, and thank you for coming.
Yeah, no, great to be here. So this is going to be a presentation that's been updated from ROSCON Japan. I think in 2021, this was the technical keynote I gave with respect to that, and then there's a few updates throughout the process here as well. I'm also a little under the weather, so if I happen to lose my train of thoughts, just let you know it has been known to happen, but I think we should be good here. So yeah, something I want to put out here is also that we've focused a lot on branding for NAV2. Just like Picnic has done for Move It. Historically, navigation has just been this, here's this project and there's no documentation, no branding and stuff. So you'll start to see some cohesive design language throughout a lot of the navigation documentation in the coming weeks and months. I work at Samsung Research. I'm the senior technical lead of the open source group, and I work on the robot operating system primarily. We support a number of different projects within the TSC within the robot operating system. So there's navigation, which is obviously mobile robot work. There's Move It, which does manipulation. There's the ROS2 core libraries, which do the communication, all the kind of good stuff you expect to find a ROS. There's control for manipulators as well as other types of robots. Really, ROS contains a litany of different projects that can be used to build scalable robot systems. And the TSC is kind of the overarching body to kind of drive the direction of the project and set different requirements based on what we're doing currently within ROS. I also lead the navigation working group about NAV2, which we'll talk about down here in the presentation. And I've developed a number of different ROS1 and ROS2 packages over the years, primarily in the mobile robot space, but a few other kind of just nice utilities here and there as well. Before joining Samsung, I was the lead robotics engineer at a company called Symbi Robotics, which is still relatively small, but they have a number of robots out there doing useful work. And I helped build basically most of the navigation system for a robot which goes around retail stores and audits the shelves for inventory. So while I was there, I worked on different social behaviors of interacting with people. So I am very passionate about understanding about how people want to interact with robots, how people actually interact with robots, and trying to make the navigation systems not just optimal in terms of getting to your goal quickly, but also what is the experience that people have when they interact with that robot system. So trying to balance out the requirements of the most efficient navigation along with bystanders around in the space, making sure that things are safe and things that are socially acceptable. Because oftentimes robots will do funky things otherwise. And prior to that, I worked on the Asteroid Redirect mission and Restore L missions at NASA Goddard out in DC. So I did mostly grappling dynamics work there. So that's a whole other set of work. So today, this presentation is kind of like blocked off into kind of three major kind of sections. The first is like talking about the motivations behind navigation 2, about why it is we're doing what we're doing, what the issues are, how we've gotten to the position we are in today. The second is talking about NAV2 itself, so describing the system, some of the configuration options you have available to you, how it's designed, why it's designed that way, these kinds of things. And then at the end, I want to talk a bit about the community that's developed around NAV2, talk about some of the users and some of the examples of where NAV2 is being deployed in the wild. So on the motivations of NAV2, so a lot of this comes down to the ROS1 to ROS2 fork, which started not long after Willow Garage closed, but really didn't kind of come into the scene until around the 2016-2017 timeframe with the betas. So with ROS2 kind of introduced this new idea of these like production grade middlewares and being, have the option to have hard real-time systems operating, working on embedded small ARMs, CPUs and microprocessors, and these kinds of things. And so as NAV2, or as we were talking about moving the navigation stack from ROS1 to ROS2, we didn't just want to do a straight port, right? We wanted to actually use some of the new design philosophies from ROS2 and take that and run with it at the higher level kind of autonomy capabilities of the navigation stack. So ROS2 itself, is built on 10 years plus lessons learned from the ROS1 system. The folks at Open Robotics have been often working on these systems for as long as ROS has existed and are the de facto experts on how you build robot middlewares. So they've learned a lot over the course of ROS1. and found a number of different things that they needed to have updated to make ROS2 better and more capable. Along those lines, making sure that this is a production-ready middleware and not some research framework for research robots. That this was something that could be put on your Roomba. These are things that could be put on autonomous drones or in military applications or on various other large-scale autonomous systems. That when you made something, you knew it was going to work and it's going to be reliable. There's a lot of focus on quality and reliability. While the documentation is still a little lacking in ROS2, we're slowly getting there, but it takes time to make all that documentation. But the actual code quality is incredibly high. Everything has very high test coverage. We're working with middleware frameworks, the DDS systems that have the ability to be run on small embedded systems and support hard real-time systems and RTOSs. So we definitely have a lot more capability there to make mature systems than we ever had in ROS1. Two of the kind of defining motivations behind ROS2 is more and more we're seeing that both in factories or in research, people want to be doing these multi-robot systems. And that was something that ROS1 just really could not handle very well. There's actually a paper that I've written with the folks at Open Robotics that's coming out in the coming weeks that's going to discuss some of the limitations of specific companies about how ROS1 limited them to have very small fleets of robots. I think Auto Motors, which is a spinoff of ClearPath Robotics, was only able to have around 25-ish robots on a single network talking to each other with ROS1. But with ROS2, they expanded easily into the 200 to 300 range, pretty much as many robots as they would need in a given facility. So ROS2 has really made a big difference with the multi-robot systems that we're seeing in the current robotics trends. And the last is just security. More and more, especially is what you see is happening in Europe. Security and digital security is incredibly important, and this is something that the robotics ecosystem has traditionally ignored. And there's been some given researchers which are very interested in this area, but it hasn't really kind of spun out from that research area into the production middlewares and systems being very sensitive about security. So since we've moved to DDS with ROS2, we have the ability to have best-in-class security given to us by the DDS specification. So why I really like this image right here, this is from the DARPA Subterranean Challenge. While I don't actually believe this team did use ROS2, although the Ghost robot you see here, the legged robot, they do use ROS2 as part of their internal systems. I think this is a really good demonstration of all the different reasons about why ROS2 is really important, about what the kind of modern trends are. You see both many robots that have to interact with each other on a single system. You're seeing that it's going into a mine, which has the worst networking characteristics ever. You can't just easily connect to each other over a Wi-Fi network. You have to create all these bridging systems. You also have hard real-time systems on the quadcopter and on the legged robot to deal with the local control. Quality is very important for this kind of work. So I think this is very representative of a case where that kind of hits all the major bullet points of importance about ROS2. So in terms of more specifically kind of going into navigation, what are some of the trends that have changed since the navigation stack was made in 2012 timeframe? At that point we had the PR2, the Turtlebot program was just getting off the ground. People didn't have robots in their homes except for maybe a Roomba. There really weren't robots deployed on a large scale in warehouses. The robots were the future, but not something that's accessible today. And what we're seeing today is that there are robots now in all these locations, and they're doing different things than any of the assumptions that we made in the very early days of developing the navigation stack. So you see in the center here, with Tally, the robot from CSULB Robotics, we're interacting in human-filled spaces alongside people. These robots aren't running in the middle of the night when nobody's there. They're running 5 times a day, every day, with store traffic. And so we need to deal with those kind of situations. With the Subterranean Challenge here with the ClearPath robot, we're working on non-planar, non-flat environments that are going to be really bumpy, that are natural or generally speaking unstructured, and we need to deal with these situations as well. With the legged robots, those are obviously very complex systems that need special affordances made in their time systems. With Locust Robotics, we now have hundreds of robots deployed in a facility. I think that the publicly stated number for them is there's a single facility with over 1,000 robots running at any given time. These are just incredible scale. I mean, even working professionally in robotics, it's honestly kind of mind-boggling to think about how many robots are working in a given facility, and all the different challenges that poses. We also have robots not just on the ground, but then we have robots flying through the skies, and they need to deal with runways and the semantics about where can they land, where can't they land, where can they drive, where can't they drive, why can they drive those places. We need to deal with more semantic information than ever before for these intelligent systems. And then finally, we have these delivery robots, right? We have things actually on the sidewalk that are going to be interacting with people, dealing with having to go around like dog poop, and dealing with curbs and intersections, and lots of very complex interactions. So really, like, going from a PR2 where the novelty of having a robot that would just drive through your home, that's today, and this is also today in the navigation system. Then ROS really has not developed since those early days in order to support these use cases that we definitely want to be supporting moving forward. So so how do we get there? There's a big shift in pretty much every respect on the navigation system. So, and I think the two big words here are being high quality and being modern to support these kinds of systems. So understanding the requirements of legged robots and Ackerman steering cars and outdoor and structured environments or urban environments, trying to understand what technologies they need and providing that with the navigation stack, or at least providing the interfaces required so that customization can be made to support it moving forward. So we're very big on testing. Michael Ferguson, the former CTO of Fetch Robotics, has been part-time maintaining the navigation stack for years, and his major gripe is that he couldn't merge in major changes because he wasn't relying on the systems anymore. And they were quite old and they had no testing. So when somebody submitted a pull request of 1,000 lines to fundamentally rewrite some sort of package to improve it, it was very difficult to merge in that work, or generally speaking, it was impossible to merge in that work. Because you couldn't be confident that pull request didn't fundamentally break systems, that he had to go through and manually edge test everything on robots he had access to. And so moving forward, we definitely are very focused on testing, so we can be very confident in our decisions when we make them and we merge in new systems and new algorithms. It is a strict requirement at this point that any new software has at least 90% test coverage included on it. All new packages must have 90%. Any given patch must not drop the test coverage percentages. Right now, we're about 88-89% test coverage, and we want to be at 90% plus moving forward in the steady state. We also, along those lines, we need to have like professional support and documentation. This can't be a situation where some students need to go through the move-based code in order to understand the state machine of what's happening. We need to have documentation so that folks can understand what the dials they have access to and what those dials do, what the configuration points they have, and how they can interact with them. So having that professional support to ensure quality and modernization, as well as having the documentation so that folks can interact with the framework as a framework and not have to understand exactly what's happening under the hood all the time. We also want to be leveraging all the new ROS2 features and design philosophies. So in the previous slide, we talked a bit about some of the reasons why ROS2 need to be created. So we want to be very mindful of that and be very mindful of the processes involved that Open Robotics is implementing. So they have lots of policies about testing, lots of policies about quality control, release cycles, API compatibility, these kinds of things. And we're bringing all of that, all those design philosophies back up all the way to the autonomy system within the navigation ecosystem. Another thing that is a kind of a personal goal of mine is to re-centralize navigation development. So with MoveBase way back when, basically companies started with this thing and said, okay, I need to modify this, and it's not easily done through a plugin interface. I'm going to fork it and make all my changes here. And then over time, the forks get more complex and more specialized. And at that point, it's basically impossible to merge that work back into the central ecosystem. Or they started with building their own system from scratch. So what I want to be doing is say, work with companies that are producing robots and say, hey, let's use this system, but as you make modifications, let's merge this back in. I want to be a very active maintainer to encourage contributions from companies back into the system, so that we're not having these distributed forks and all these different developments going on. I want to keep things centralized so that everyone can make use of all the modern improvements being made by various companies for their systems. And so far, we've been very successful at that. We've had lots of, especially with having this professional support. So we have very quick turnaround on pull requests and issue tickets and emails that more people are willing to contribute back because there's a quick cycle from, okay, we made this thing, how do I get this back to the system versus being delayed for weeks and months and eventually just kind of giving up interest and contributing back. So we've definitely very much so improved there, and we've been better for that. We've had new algorithms, we have new servers, we have ideas about systems that people need for urban mobility, and we've been bringing that work back home so that everyone in all contexts can use that improvement. Another is more independence in the framework, and we'll talk about that with behavior trees in later slides. We've also updated algorithms and added a number of new features. So we have new planning algorithms, we have new perception plugins, we have new features like map editing, keep out zones. We're currently working on speed limiters and safety nodes, velocity smoothers, a bunch of this kind of stuff, so that this is really going to be a one-stop shop of generic needs for autonomous systems. There's always going to be situations where you need to have a custom docking algorithm, or you need to have a custom autonomy system, and that's perfectly fine. So we want to make sure that we're providing the interfaces publicly that are well documented about how you can build your own customizations. But we want to be able to give the common things that we understand that people need to work with, and make that just freely available so that we can kickstart companies and kickstart the robot revolution much faster. So let's go into NAV2 itself now. I talk about it's ROS2's production solution to navigation, and that's true. There are I think at this point 80 companies that are using. My understanding is the current master or a Fortis or commit NAV2 in their production systems. They're not forking it and making all these modifications, then using that. They're using the direct binaries we provide them in their ROS distribution or in Whirlwind to get the most modern features and that kind of stuff. It is being used by many companies and thousands of robots globally today, right now. It's not a future thing, and this is the current state of the art. And we're using behavior trees to orchestrate the navigation system. So in ROS1, we had the state machine where we plan at some given rate, and then occasionally we also compute control efforts at a certain rate. This is all happening in a big state machine in MoveBase that is not configurable. So instead, we replace this entirely with a behavior tree-based solution that's defined by behavior tree XML files. So completely configurable. You can define any logic you wish. I mean, it could potentially not even be navigation related, but hopefully it's navigation related. All of the different behavior tree nodes that the behavior tree is interacting with are themselves plugins. And so there's no requirement to fork the system to add new behavior tree nodes. At any time, you can create your new libraries, and it will be dynamically loaded at runtime when you load that XML without any effort on your part. So you can create as simple or as complex navigation systems as you wish using the behavior tree navigation system. We're also designed on many independent modular servers. So rather than having a single process MoveBase, which contains all the perception algorithms, all of the navigators, all of the different logic, they are now separated in many different action servers, which gives you the ability both to just completely replace one of them if that's not relevant for your system, or to rewrite portions of it if you want to use a different environmental representation than what we have available. You can pick and choose any of these things you wish, swap them out, rewrite them, do whatever you like, or even add in additional servers to do your additional work. So I know, like, for instance, a common modification that folks might make is in the controller server, actually just removing that entirely, and then you writing something in Python so they can leverage all the different AI libraries that are available to you in Python to create prototypes of reinforcement learning systems for control. And that's just as easy as changing one launch file and adding in your server, and poof, you can work with whatever it is you're interested in. As mentioned before, we have a number of different new features and algorithms, which we'll talk about in future slides. We have many more runtime selectable plugin interfaces. So in the behavior tree, we have the XML files, we have the behavior tree nodes themselves. In the controllers, we have progress checkers, we have goal checkers, we have the controllers themselves, we have planners, we have independent recovery behavior APIs, we have smoothing interfaces. There's many places where you can plug in your algorithms that can be just dynamically loaded at runtime, that don't involve you having to modify anything in central code of the navigation stack. We also have support for all robot types at this point. So that means differential drive, omnidirectional, Ackerman steering, car-like robots, and legged robots. And we have users of navigation in all 4 of those verticals using the default algorithms available in navigation for their systems. So these are proven algorithms to be workable in all these systems currently by commercial users. And we're also focused on testing and quality, as I mentioned before. I think quality is a huge documentation, test coverage, making sure that people can be confident that they select this as their navigation system, that this is something they can use years down the line, that we're going to be very careful at API compatibility, and this is going to be professionally maintained. And as I previously mentioned, it's easily extensible. If you want to swap out the controller server in Python, very easy to do that. If you want to add in new servers to do different capabilities, very easy to do that. You want to change plugin interfaces, very easy. You know, there are many places that you can modify the system so you can build whatever it is that you're interested in doing. So a little on behavior trees. So this is I could give like a 2-hour talk just on behavior trees. So like this is the most pared down I could possibly give it for understanding. But essentially, like, rather than a finite state machine or a hierarchical state machine, you know, behavior trees are set up as trees where the leaf nodes are the actions you wish to have performed. And the other nodes in the system are usually going to be control flow to control how it is the behavior tree is being ticked through execution. So what this behavior tree represents is like the most simplistic behavior tree that you can get, and it's relatively analog to what you'd expect from behavior in ROS1 navigation. So kind of going through this flow very quickly. So the first thing we have is this recovery node. So that's doing is that on the left-hand side, we have the primary navigation tree. And if for any reason at any time that fails and returns a failure notification, it's going to go to the fallback, which is this, what I refer to as the recovery subtree. And this is going to be then executing the global system level recovery behaviors to get the robot out of that situation. So on the navigation side, you can see that we have this rate controller on compute path to pose. So that's the same thing as throttling your replanning rate to 1 Hertz, 10 Hertz, whatever it is you're interested in doing. And so by default, we replan at 1 Hertz. And if for any reason that computing the path is impossible, then we will clear the global cost map as a contextual recovery so that we can see if we can we're then able to compute a valid path. Once we have this path, which has been computed at the rate controller frequency, then it's passed off over to the follow path action, which that calls then the controller server, passes off the path and says, hey, I want you to follow this. And if for some reason that action fails, then it would clear the local cost map as its contextual recovery to see if that would help fix the problem. But if we end up at a situation where we can't compute a path and the global cost map doesn't help, or we can't follow that path for some reason and clearing the local cost map can't help, then we go over to this recovery subtree. And the first thing you see here is we have this checking if the goal has been updated. And this is just making sure that at any given time, when we are executing the system, if you request a different goal, it's going to be instantly reactive to that, even if we're in a recovery situation. Then the sequence stars, basically in order, we're going to be clearing the local cost map, then the global cost map, then spin, then wait. And in between each of those recovery actions, we're going to go back to the navigation tree and see if we can now successfully navigate. If we can't, then we're going to go basically to the next in the row and the next and the next. So this is essentially the state or the behavior tree representation of the move-based state machine. And for a long time, this was the default behavior tree within the navigation stack. We've added a number of more bells and whistles at this point than what this represents, but this is the easiest to kind of explain at a high level. It is very similar to this, but moving forward, we have many additional plans to create much more intelligent behavior. So I think when I think of robot behavior, I think 2 locations is where this word's represented. The first is the autonomy system, so how it is that information is flowed through the system and what we do when. And the second is the local trajectory planning algorithm, which is often what people interact when people are looking at the robot system. What you're seeing is a local trajectory planner. So that's often like a big behavioral perspective to bystanders. And so it's very important to make that very dynamic and very fluid in ways that people understand. But this is the higher level of what we do win kind of behaviors. So over time, there are some problems with move base. For instance, if you are in a middle of an aisle and you'd like to go to the middle of an aisle next over to it, there are two paths potentially of relatively equal cost that the path planner could be oscillating between. So we've recently merged in behavior trees in the navigation stack, which resolves that problem by instead planning at a significantly reduced frequency. I think we only plan once every 15 seconds. But in part of that, then we're actually checking if that path is valid through execution. If at any point that path has become invalidated because there's something in the way or the costs have changed too significantly, so that clearly the environment has shifted, then it will execute contextual replans when required. So that removes a lot of the oscillation issues pretty much entirely from the system, and really involves just minorly rearranging these behavior tree nodes and adding one additional node. So there's a lot of things you can do with just minor tweaks to solve these like long-standing problems of the navigation stack, because we have the ability to interact with these behavior trees ourselves. So to go through kind of more the specifics of the nav2 stack and what you have available to you within that system. So the first is the things we just grabbed from ROS1. So we just grabbed AMCL and SLAM toolbox for localization. We grabbed the Nav10 planner. We chose not to port the global planner at all. That has some quirks in it. It was essentially a refactor of the Nav10 planner itself, with a little bit less performance, much more understandable code. But the Nav10 planner has been pretty bulletproof for the last decade. So we looked at this and said, we'd rather have the thing that fewer people understand, but just works well out of the box, and it hasn't had any bugs that have required fixing, in about a decade. We've also ported over the map server with a pretty significant refactor, but it's roughly speaking the same API that you'd expect. And then we also ported over CostMap 2D, which is almost entirely the same. We've added some additional plugins to it, which we'll talk about later, but we now have processing for sonar sensors built into the stack, keep out zones, and speed restricted zones. And there's more coming as well, but everything you expect to find in CostMap 2D is still here as well.
Steve, I can't
Yeah.
help but notice move base is missing.
Yes, it's completely replaced by the behavior trees. There's no concept of move base anymore, because now the behavior trees are what's defining your flow of information. So there is no move base. The behavior tree navigator is the full replacement to move base.
Got it. Thanks.
So yeah, so this graphic will help explain that as well. So instead of having a state machine which is calling the controller and calling the planner and execute recovery behaviors in a statically set C++ code, now you have this behavior tree navigator server, which then has that behavior tree that you can modify however you like, and then those behavior tree nodes will interact with the servers to define your logic. So it's making the statically set state machine into a behavior tree that you can change at runtime or specify however you like. So for the design characteristics, some of the really important things here, this XML file for the behavior tree logic. So the behavior tree I showed you before, that's configurable. You can do anything you want with it. It's defined as an XML file, and there's a parameter at runtime that you can specify which behavior tree that you'd like to use. There's also, from the autonomy systems perspective, you can also request a specific behavior tree to utilize as well. So you're not restricted to one behavior tree per BT Navigator instance. Your autonomy system can specify for each individual task what behavior tree to use in case there's differences in how you want the robot to behave in different situations. For instance, like a Roomba, you might want to have do your coverage path, as when you're in the execution mode. But then if you decide your battery is low, you'd want to switch behavior trees to driving to the dock and docking. So you might have two different behavior trees to have two different behaviors of your robot. You can also easily swap out these servers, as I mentioned before, with the Python controller server example I showed here. Another interesting thing is that because these are independent servers, they can be run not only separately, but also on different CPUs, or even potentially not even on the robot at all and run in the cloud. So you could be in a situation where maybe you have a giant multi-robot system, and so the planner server doesn't make sense for you. So you just delete that entirely, or you'd replace it with a cloud instance that's optimizing for many different robot paths at the same time. You could also run the controller on a microprocessor if you like. And so really these are interacting over action APIs. So, anything that you can stick ROS2 on, then you can run any of these individual servers wherever you like on your system. So you can do load balancing, or you can have, work with a bunch of tiny little ARM CPUs versus, one massive Intel CPU. You have a lot of flexibility about where things run and when. And the last couple things here are the plugin interfaces that I've talked about at length already on. So yeah, you have a lot more Python. You have a lot more plugin interfaces you can work with to specify how your system operates. And those are represented in these diagrams as like the little squares you see in the different servers. I think about those as the plugins. Something that's worth mentioning is that in the planner server and the controller server, actually in all these servers, you're not restricted to a single plugin algorithm. So you're not restricted to having one path planner. You can have n path planners. So you might want to have one that you use as your general path planner, and then another that's your backup. That's maybe more expensive and heavier to run, but will guarantee you outputs if they exist. Or you might want to try different control schema in different situations. Maybe you want to have exact path following behavior in open free spaces, but then when you're working in crowds, you might want to switch to something like an MPC or an MPPI controller, so that you can have a lot more dynamic behavior in dealing with the current state of the environment with lots of moving obstacles. So you have the ability to then select those within the behavior tree, so then your behavior tree can contextually have that all set up so that you can have different algorithms run in different situations or as different fallbacks. On the algorithms themselves, so yeah, I mentioned that there are, we now support pretty much every class of modern robot system out there. And these are the algorithms you have for each of them, which the thing I really like to note here is that for every single one of these, you don't have just one option, you have many options. Like, so you can use, if you want different kinds of behaviors or different kinds of systems, you have the ability to do so. So I know there's a lot of letters here that you might not be familiar with. So RPP is the regulated pure pursuit controller. We added that in the middle of last year. It's essentially a pure pursuit geometric controller, and the regulated, the R at the front, is representative of having some heuristic functions on the linear speed, so that we can slow down in certain situations where most robots would like to slow down. For instance, if you're doing a sharp right turn, you might want to slow down just in case there's something on the other side of that, or you have a bunch of load on your robot. You don't want to dump that just by momentum. This also will slow down in higher cost regions, so that if you're in confined spaces, your robot will slow down as well, so you have more precise control. We also have DWB, which is a DWA, which is a dynamic window approach controller. This is the controller you expect to find in ROS1 navigation. So if you've been used in the past, that's essentially what you'd expect. It's been refactored by David Liu at Locus Robotics to have more plugin interfaces and be a bit of a cleaner code base, but it has the essentially the same behavior. We also have TEB, which is a time-elastic band controller that's also been available from ROS1 in ROS2. And then we also have this MPPIC controller, and this is a little future looking. That's my current work. That's not yet available, but it is terminally going to be available probably in the second half of this year. And that's a model predictive path integral controller, which I don't want to get into too much of the weeds of that at this moment. So those are the controllers that you have available to you, and most of them will work across the broad range of robot systems. We've made sure we've added motion models, which are supportive by configuration, and most of the controllers, so that you can use them in different situations with different behaviors. In terms of path planning, we have the Theta Star planner, which basically just creates straight line paths as far as it's possible. It is cost aware, so you still will get some of the more curvy behavior. Like I said, I have lack of words to describe this, but it's not necessarily just a straight line path about binary obstacles. It's going to take cost information.
What kind of behavior?
Like it's going to create it creates lots of straight line behavior. So it's going to give you many curvy? Straight lines. Sorry.
Did you say curvy?
Well, Sorry.
Just checking.
So I use the term cost aware, but then you're gonna ask me what that means, and then I don't have a good definition for you. But I mean, basically it's gonna take into account cost information, just like an A-star would in a cost map. But what's happening with Theta Star though is that by default, right, that's just taking a binary collision information. It's gonna create often just like straight line segments at different angles to create the shortest path. But we've modified that to include cost information into that objective function. So it's not like a pure Theta Star behavior. It is still cost aware. So you're going to still get some repulsion away from obstacles based on the cost information. But there are weights you can set about the dials. Like, would you rather have traditional A-star behavior or Theta Star behavior, or would you rather have a little bit more like curved cost aware behavior?
I'm just trying to get at your adjective. It was curvy, right?
Correct.
Okay, thank you.
Then we have the NavFN planner, which was available from ROS 1 that we've talked about already. Then there's a new planning framework that I created in 2020 and early 2021 called the SMAC planner. And this is a templated A-star, which then allows you to create a number of different node behaviors so that you can create different search-based planners based on an A-star with different search criteria or heuristics and this kind of stuff. And within that framework, we've created a 2D A-star that, you know, it's complementary to any of the other 2D planners. But the prime examples of the power of this is in a hybrid A-star and a state lattice planner implementation. Both of these are going to be kinematically feasible, which means that it's going to take into account the kinematic constraints on different types of robots. So that's what the primary way that we are able to support now Ackerman and legged robots is by following the motion model that is available by these different robot systems. So the hybrid A-star planner is meant specifically for Ackerman steering vehicles, and the state lattice planner can use an arbitrary lattice to represent any arbitrary kinematic model. We do provide a lattice generator so that you can do this, at home based on your given constraints. But you can easily create different lattices for more bespoke drivetrains are not easily described in literature, but certainly anything that's very classical, these will support. So in terms of some of the features, I'm just going to kind of let's do this real quick here, but this is an introductory slide to kind of to explain the setup here. So on the left-hand side, we have a map of this little Amazon warehouse world that was provided to us by AWS Robotics. And on the right, this is a top-down view of that same environment in Gazebo. So this is the simulated world the robots will be interacting in. So for the next few pages, you're going to see that I'm drawing on top of these objects. But this is the baseline that you should understand about it. So the first thing we have is speed restricted zones. So within the cost map, we now have what we refer to as cost map filters, and we have a few implementations of those cost map filters to create kind of common behavior that most robot companies usually create internally, but then nobody open sources because it for whatever reason. And so we wanted to make kind of some centralized implementations of these things that are high quality and well integrated into the system. And we've actually found that most companies have moved over to our system versus what they've built because it's a little bit cleaner and they don't have to maintain it and that kind of stuff. So in the speed restricted zones, what you see on top of that on that map is a mask of cost. And what the cost map filters do is you bring in this mask into the cost map filter and you give it a function about how it should interpret those cost values and to do different operations on them. So for the speed zones, these costs actually translate into like the maximum speeds the robot can achieve. So you can see that in this like central green aisleway, we set the robot to go as fast as it likes. It can go the maximum speed because these are like specific areas the robot is is allowed to move freely. And then outside of those zones, we then reduce the speed significantly so that if the robot is like going into a shelving area where there might be forklifts, there might be people working, that the robot is to be reducing its speed rather significantly so that for whatever safety reasons that you might be interested in a warehouse environment. And then these gray areas where we have kind of these marked off caution tape areas in the center. Those are areas maybe that the robot is frequently working in around people, but for efficiency reasons need to go a bit faster. So we set that to gray to be a 50% or something of the maximum speed or between the lowest speed and the highest speed, so that the robot can be a little safe in those environments but still get the job done. Complementary to that, with the same logic, we have keep out zones. So you can specify areas where the robot is not allowed to navigate, and then those are interpreted by the cost maps at the algorithm level, so that these are considered to be no-go zones. So the planner will not plan in them, the controller will not control in them, so that it avoids these areas in general. You can also set these to not only be keep out, but larger weighted areas. So rather than just being straight black where you say don't go there, you could make this a more gray region to say, you know, we'd like you not to go here, but if you have to, you can. You know, using the algorithms to say, I'd rather you take a longer path around, except for if it's too long of a path. In that case, maybe it is worth going through these areas. So you can have those both like the weighted region as well as the keep out behavior. Just like in ROS1 navigation, you have the navigate to pose behavior. So that's just this usual, I say, hey, robot, I'm here, I want to go there, go do it for me. And it's going to get you to that final location. But I've also created what referred to as navigate through poses. So instead of specifying one pose you'd like to be as a goal, you specify an array of poses that you'd like the robot to go through. So you can think about these as hard physical constraints on the planner to say, you must go through these regions in order to execute your path. So this is very simply implemented rather than trying to make a super fancy path planner that takes these hard constraints and creates a cohesive path. Instead, what we do is we request the path planner create navigation to pose requests from pose 1 to 2, 2 to 3, 3 to 4, 4 to 5, etc. And then we concatenate those paths into a final path to actually execute. When this is paired with a planner like the Hybrid Star planner and the State Labs planner, which are both kinematically feasible, then these paths are guaranteed to be smoothly continuous because we are taking into account the physical constraints of the robot. So when we're ending a certain orientation and starting another orientation, it's going to be creating paths that they'll start and end in those orientations. So you have a very smooth maneuver that occurs. When you do just a traditional 2D A star, any of the other non-feasible or the infeasible planners, then at each of these points it might be discontinuous, just be aware of that. We also have waypoint followers and task executors. So what this means that rather than creating a single path, the robot will go through continuously, which will not stop at any of the given via points. It's just going through them. The waypoint follower will actually stop at each of these waypoints and execute some sort of task. And so we have an additional plugin interface within this waypoint follower to make a simple autonomy system that one might want to use for a proof of concept or for research, so that the robot will stop at a position and then it'll execute the plugin that you've specified. And that could do anything from take a picture on a shelf for a retail auditing example, or pause for user input to wait for a person to say if they put a box onto the robot, or whatever it is that you're interested in doing at each of these waypoints. And we provide a few example task executors to do pausing for a fixed period of time, waiting for user input, and taking an image as 3 examples of different executors you could do with this. We also have a lot of resources available. So we have in RViz, we have a little panel you can use to interact with the system for the lifecycle and using all the features I mentioned before. You can use through the UI for testing and evaluation, getting started, that kind of stuff. We also provide a Python 3 simple commander API that was born out of a presentation I was giving to the ROS Developers Conference that I needed to create a bunch of just kind of like simple autonomy examples. In fact, I think that the videos you saw in the previous slides were from that presentation. And so I needed to create like a simple way to make a bunch of autonomous systems. And it's really easy to do that in Python. So I essentially just wrapped all the action interfaces for all the different action servers, the behavior tree navigator, and all those kind of things into a client library, so that you could just use you could import this library and say navigator go to pose and give it a pose, and it'll just do it, and you don't have to worry about any of the ROS2 stuff happening behind the scenes. There's no interacting with futures, there's no interacting with RCL directly. You just interact with this client, and you can basically do all the major things you'd expect to be able to do with it. And documentation. So on navigation.ros.org, you see kind of scrolling through this video, we have tons and tons of documentation, build, install, configuration, what plugins exist, how to create plugins, different tutorials. We have a centralized list of all the known nav2 plugins that are available in the ecosystem, as well as help assistance for setting up your robot for that very first time. And we're constantly adding more documentation to this, especially as people ask me questions. If I hear the same question 3 times in a short period, I'll usually write a documentation page about it. So this is a constantly growing and evolving part of the project. Yeah, and then quality. So yeah, as we mentioned before, we're taking a lot of design philosophy from the ROS2 ecosystem. So we use all the same linting and stack analysis tools that ROS2 does. So if you read any code in ROS2, it's going to look exactly the same no matter what project. We're also the documentation, as I previously mentioned. Typically, when we create new algorithms, we try to create some academic papers so that there are affordable descriptions of what's going on and why. I'm not personally too focused on like, oh, it gets published in some, fancy schmancy journal. It's more about, hey, we have something out here that people can understand. And often we get criticized in peer review that we're too open or whatever, that we're not using enough research jargon, because we really want these to be very approachable papers for everyone to read. I don't want to show somebody how smart I am. I don't really care about that. My goal is to describe this thing in a way that people can use as a reference into the future. We also do full CI simulation testing. So we have gazebo instances that run in our CI that put the robot through its paces in a number of different environments, so that we test basic navigation behavior of the full system and not just doing unit level testing. And we have about 88%, 88, 89, depending on the day. We have a couple of flaky tests we're working through. Test coverage of the entire system. My goal is to keep it at steady state at 90%. And we've been slowly creeping up on that goal over the years. I think when I took over the project is around 40%, and then we got 40 to 60 pretty quickly, 60 to 70 pretty quickly, and it's a snail's pace to get those last few percentages where you're handling mostly just weird edge cases that weren't handled by other tests. Whew, all right, well, that's all the nav2 stuff. And so this is just where we see fun pictures of robots from the community. So these are a small subset of the companies using nav2 in production. These are ones that I was given explicit permission to share publicly and to show images of. So around here, a couple of the interesting ones are this TRI, Toyota Research Institute robot. They had a bunch of teleoperation robots and other robot systems throughout the Tokyo Olympics, and those were running nav2 on them, and I believe actually just out of the box from Foxy. So if you see those things falling over and setting on fire, that's my fault. But if they weren't falling over and setting on fire, that's nav2 right there. We also have Elroy Air, who is an autonomous drone, eVTOL drone company out in Silicon Valley, and they're using nav2 for ground operations. So working on the runway, taxiing to their warehouses to fill up with new content and that kind of stuff. Their in-air system is obviously very different from what navigation provides. So that's obviously separate. We also have Neobotics, which builds a large slew of warehouse robot systems. I can't name the company, but you see this prototype of robot in the lower right corner as well that is working on picking up garbage and this kind of stuff in park environments. So helping clean up parks in Europe essentially. Huawei is using it for a bunch of their research. There's just a bunch of robot systems that are using this. Mike Ferguson has set up nav2 on his unbounded robotics robot as well. And there's a bunch of folks using it, right? LG, Samsung, iRobot is playing around with it for their Create 3 platform that they've recently released. There's a bunch of folks using it for a lot of interesting tasks. I think the most interesting one that I can share is that there's a guy in New Zealand who's using it for library automation. So it's taking the books from the book drop off and helping to sort them and put them back on the shelves. So it's nice to think that my work is helping libraries. That's really neat. Yeah, so a quick video here. So this is kind of going over some of the other publicly known nav2 users. So this is Leica Robotics, who builds primarily industrial robots for warehouses and that kind of stuff, but they have a number of different add-ons like security robots like you see here, which are using nav2 for their systems. They previously had a ROS1 based solution on behavior trees with many of the different modifications that we made to the system. And when they realized how similar what we were working on was to what they built internally, they actually abandoned largely what they were doing internally over to the nav2 system. And they're using what's available in binary form as well. So they're not making lots of modifications. They're using what nav2 looks like out of the box every day for their applications. And I think next video, maybe it's a little long. There we go. All right, so LG has a number of these proof of concept robots for food delivery in restaurants and help assisting in stores and retail hospitality, similar to what Savio does. And these, while these are proof of concepts and not production systems, they are using nav to execute these different behaviors for these proof of concepts that are running in the various stores. And just because we're running short on time, I'm not gonna let this video play out, but there's a few other cool videos here, and I can show the presentation later that you can watch this at full length if you like. So on the roadmap, so kind of first step we had back in 2019 was just getting things to work in general. I mean, just basically get to a ROS1 level of functionality in ROS2 using the behavior tree system, and we knocked that out back in 2019. Then my goal for 2020 was to basically expand the support for all different types of bases, and that's why there's been a lot of work, especially the path planning side of things, to get pathplanners that can support Ackermann and legged robot systems, as well as better support for omnidirectional robots than is currently available. So we've also knocked that out. We now have both controller and planning algorithms that are functional for essentially all types of robot systems that are currently available. And we're currently working on this third stage, and we started this in 2021, and this will probably be going on for the next several years to basically build out all these more advanced capabilities that are necessary, that are common for robot companies to build into their system. So the keep out zones, the speed restricted zones that we previously talked about, assisted teleop features so that people can teleop the robot remotely out of bad situations, which is common for service robots. Safety nodes to make sure that the system is safe at all times and isn't going to cause collisions. Docking behaviors, specifically modeling dynamic obstacles and processing that through the algorithm so that we're not just assuming a static world environment when we view obstacles. Well, the current Cosmo implementation, I mean, it will represent the static motion of robots or of other agents in the environment. It's just taking a static snapshot and isn't encoding any sort of velocity information. So there's a bit of work that could be done to improve that behavior. Although many of the dynamic obstacle tracking path trackers are quite good actually at even just using that representation to avoid dynamic obstacles, but it'd be much better to have explicit representations that we can bake into different planning control systems. We then kind of in parallel with that one, I think we're going to be working on 4 and 5 as well. And so that's the support for additional types of localization of SLAM systems. So both replacing AMCL and SLAM toolbox with better, more robust framework-based systems, but also extending that for visual SLAM and 3D SLAM and localization systems. We actually have done quite a bit of work at Samsung Research on visual SLAM, and we did create some demonstrations, but ultimately we decided not to release them because we found the state of the art of vSLAM is still very immature, and we didn't want to put out integrations with things like OrbSlam 3 and OpenVSlam, these kind of stuff, if we couldn't like confidently put our name on it, that we think that these things work really well, and that I think this is good enough for a production system. So we're not, we're in the business of doing research, but we want that code to be production ready, that when we put it out, this is like a real integration, which is really going to work. And so Visual SLAM just is not at that point at the field. So we have not yet made any official integrations with that, but 3D SLAM, there are definitely 3D SLAMs out there that work very well, and so that's in our steps forward. And the last is retooling the terrain models, and that's actually kind of my bread and butter. Like that's the research I really like. That's what I like to work with. And so this is more about replacing cost maps with additional representations of the world, which are useful for especially outdoor and unstructured environments. So having the ability to use height models and 3D voxel grids and vector space representations with purely detections and no, just buffering of depth data. So we want to be able to have flexible terrain models that can use all these different methods that might be appropriate for different situations, and still then be able to plug in with all of our different algorithms. As you can imagine, that's quite a tall order. There's a lot of design work that needs to go into that, and I have pages and pages of notes about my thoughts on that subject. But we have not yet started to execute on that project, just given the scope and size of it. We've been focused more on these more directly usable features first. And once we kind of have it at a point where I feel like we have most of the common features that people are interested in, then I can kind of go put my research hat on a little bit more and work on some of those kind of interesting problems. And this is the last slide. So, this is the NAV2 community. It's not just me sitting in my dark hole doing stuff. We have tons of people involved in the project, from students. We have professional researchers. We have academics. We have several professors that we work closely with. We have corporate partners. We have companies that are using NAV2. Really, if you're just interested in this area and you have a little bit of coding or robotics know-how, there are definitely projects you can work on, and they would make a real impact. It's much like documentation. One page is nothing, but if I do a page and that guy does a page, this other guy does a page, eventually, we get something that's really interesting. And so that's essentially how most of this development works, is that everyone kind of does a little small bit of their part, and we can build a really great navigation system together as a community that way. We have bi-weekly working group meetings, which vary pretty significantly in attendance. Some weeks it's just me and my Samsung colleagues. Other weeks there's 30 people that show up. I honestly cannot tell you why it is that some meetings are that way. It's a mystery to me as well. We also have a Slack group for NAV2 where you can ask questions or get involved or work on projects or collaborate with other folks in the ecosystem, where we have already about 500 people in that Slack group. And yeah, we're always interested in having folks get involved. If you're a company, using something like NAV2 helps reduce your risk, because you're using code that other people are using, and there's more robots that are using those systems to find problems with them and help fix it. If you're a student, professional growth is a great area. We have many students that we work with that have never written a path planner before, and over the course of 6 months, I'll work with a student, and we've created the Theta Star Planner, which I wrote 0 lines of code of. That was entirely a student that was interested in learning, that I helped mentor through the design process and testing, and creating different objective functions, and it's a great professional growth experience. But yeah, you also have the ability to steal the project. If you don't like the direction we're going, or you think that there's something missing, if you put the time in, you can make the impact you want to see in the project. I'm definitely a big fan of if you're willing to put your time in, you get a significant say about where we go in the future. Yeah, and then there's a link here as well on the next slide to that Slack group if you're interested in joining. And here just a couple links. So the project here is on this GitHub address. If you post on Ross Discourse, there's a navigation subchannel for that. It's mostly announcements, but certainly you can have more conversations there as well if there was a public topic that's appropriate. And then our documentation is at navigation.ross.org, and that's where you'll see all that great documentation that I've talked about. Yeah, that's all I got.
Wow, thank you.
Thank you. That's amazing. Yeah. How's the work you're doing? Any
Great
questions?
stuff. Yeah, any questions? Yeah, I'm wondering, when people use this in industrial cases, how much are they using out of the box, and how much do they have to customize and build around it? So what are you saying that kind of
yeah? So I mean, there are many companies who are purely just using what's available in open source, and it's working very well with them. I mean, obviously they have their own add-ons for their own autonomous systems and applications they're working on, but in terms of that, they're mostly just using what's out of the box. The bigger the company is, the more specialized skill sets involved. Like, they're going to be swapping out at least algorithms, right? Maybe they have their own internal controller they prefer better for their application. But those are also things we make available to them, right? We make these plugin interfaces available because we want people to customize it to their application. I can't speak too much about like what an average company does, because I don't know that there is an average company, so to speak. And I don't have insight into everything that everyone is doing. But I can say from experience, most companies are just using the binaries that are available, and they're specifying custom behavior trees and custom plugins, but they're not having to like fork the code and make like hard modifications on the framework.
Could you explain the decision as to why you made a binary decision tree versus a finite state machine?
Well, it's more natural to model more complex behaviors and behavior trees. I find that like finite state machines basically impossible to at a certain level to create complex behaviors, but hierarchical state machines are a very complementary option to behavior trees. And I don't think that there's a technically correct choice. They're both valid. And I think that for anything you can represent behavior trees, you can do it on a hierarchical state machine and vice versa. We just preferred behavior trees because that's what users wanted. That when we surveyed folks, they wanted to work with behavior trees, or they had already built their own behavior tree navigation system internally because that wasn't available already in open source. So it's just what folks want to use, and that's also the current research trend is towards behavior trees for a lot of things. So in the last like 3 or 4 years, there's been tons and tons and tons of behavior tree papers related to robotics and AI. So I think it's very natural with the progression of technology that behavior trees are going to be more and more used everywhere.
Do you run SLAM Toolbox with nav2?
Oh, sorry. Can you repeat that?
Do you run SLAM Toolbox with nav2, or do you like create a map with SLAM Toolbox, save it, and then kill SLAM Toolbox and load in nav2?
Yeah, I run it with nav2. Yeah, so when I was deploying robots back in my last company in various stores, yeah, I mean it's running the full navigation system. So typically what we do is unpack the robot, start the SLAM session, and then just start giving it random goalposts essentially, and having the robot navigate itself through the environment to build a map, and then we'd save that map and change it to a localization mode for the actual production use of it, because we want to save that map and use that static representation of the environment.
Do you use the static? Do you use the static map when you actually do you drive around, create the map, save it, and then you run navigation in the static map, right?
Well, no, I mean you do both. Navigation's running all the time, so you use navigation to build the map in SLAM as well. But I mean, it depends what you're doing, right? If you're just if it's just for a demo, you can definitely just only run SLAM and just use SLAM as your localization system while you're doing something. But if you're staying for a long period of time, then you're going to want to save that static map so that you have some representation of the environment you can label with semantic information, right? If you have like an application where you care about you don't want the robot to go behind the counter. So
I get it. It depends. But if I leave SLAM on it, if I leave SLAM Toolbox on it, like screws up my map. So I navigate within a static map.
Okay, I mean, I can't comment on your particular situation.
Well, I like the idea of running it both, because that is towards lifelong mapping, right?
Yeah, I mean that's been possible for years. I mean, pretty much since even in early ROS 1, all the SLAM have always been API compatible with the localization system. So you've always been able to run any arbitrary SLAM algorithm in the ecosystem and run navigation at the same time.
Thank you. Thank you.
How coupled are the various components of the nav2 stack? If I wanted to just pick out some pieces to not use nav2 kind of as a bundle in and of itself, but I wanted to pick out algorithms or particular pieces, is that kind of an option, or is it better to buy into the overall architecture and then just swap out the individual boxes?
Yeah, it's a hard question to answer because, like, I mean, right, what you might have in mind versus what I have in mind are likely not the same thing. But I mean, in general, it is incredibly modular. I mean, that is a core design philosophy. You can definitely just grab the planner server if you just keep on planning. For instance, I recently wrote some tests for a benchmark paper where literally all I did was I didn't run nav2 at all. I just took the planner server through requests through it, and then created statistics in the output of the maps, of the plans. So you can definitely pick and choose each individual server that you're interested in working with. In terms of like the algorithms, that's a little different. In terms of like if I want to use my the regular pupil pursuit controller in my system over here but not use any of navigation, you could certainly do that. But the APIs were written for those plugins to interact with that framework. So you have to be providing it with the same type of information, which you can definitely do. I think your biggest constraint is going to be that it's expecting a cost map representation of the environment. And so if you don't give it a cost map, or if you don't have a cost map and whatever you're trying to pull it out on, it's just, you're going to have a really bad time trying to figure out how to make it work and hack it together. But if you're still using the cost map object, then all the planners and all the controller algorithms you can definitely just rip out and use somewhere else. You just feed the same types of information that it's expecting from the servers.
When you say server, are you saying, is that synonymous with a ROS node, a ROS service, or is that just a library that I would drop into my ROS node?
So the server are each of those modular, like the task servers I mentioned in the presentation, like the controller server, the behavior server, the recovery server, the control or the planner server, the smoother server. Those are independent processes. When you launch in a multi-threaded multi-process environment, you can also have those composed, but those are independent servers that are running with their own mains, that they're doing their own independent things. And that's how you can easily swap in and out the systems. In those diagrams I showed, and you can see on the navigation documentation, when you see those like boxes, those are independent, like separated objects. Like those are not all in one process. You can make them in one process.
Yeah, I understand. And the method of communication is ROS topics?
Actions. Mostly actions.
Gotcha.
I think the clear cost map stuff, those are services because they're instantaneous. But yeah, the planning, the control, the behaviors, those are all actions.
All right, very good. We have a question in the chat window. Does nav2 work with modified Ackermann steering, such as the open source Mars rover, which uses Ackermann steering for both front and rear wheels?
So that's an example of like a bespoke non-traditional solution. So will it work? Probably. I mean, almost definitely it'll probably work fine. But if you wanted to like have guarantees, right? Like where you specifically model the kinematics of this robot and you use that in part of the planner to guarantee that it'll always work, right? Versus like generally speaking, hand waving, it'll probably work. That's what the state lattice planner is for. So that state lattice planner takes in an arbitrary set of motion primitives that you can utilize to represent the motion model of your robot. So we by default provide a generator which will provide you Ackermann omnidirectional and differential drive based primitive sets that generate a lattice. And you can generate that with whatever the kinematic parameters of your robot are, and then you have this lattice file that you throw into the planner, and the planner uses that to actually plan routes. So if you had a custom bespoke kind of solution, you would have to generate that minimum primitive set, which describes the available motions of your robot. But then once you had that, then you just you shove it through the algorithms that are already there, and then everything should work fine from that point.
Very cool. Thank you.
All right, thanks, people. Thank you very much, Steve. That was amazing.
Thank you.
Yeah, Steve, thank you.
Thanks, yeah.
And with that being said, we are a little so we are going to stop the recording at this moment, and we are going to take our lunch break.
Example robot. We were some time ago at the Homebrew Robotics Club. I say this, it was probably 4 or 5 months ago, creating an example or a sample robot project. And we wanted to make it both virtual and physical, and make it flexible, modular, and scalable. Okay. And so and we're all into ROS at the HBRC, so of course ROS would be incorporated in it, but actually to be kind of a sample ROS package. And so as we were going through the discussion online, there were a lot of good websites being posted and stuff, and we captured them. And along the way was this Lino robot project. There, I just posted it into the chat, and this is it. Am I sharing my screen? No.
No,
Let me share my screen before I start talking about it. Share screen. Okay, so this is the Lino robot project. They've got a Here you on your on your host computer, you would run the nav2 stack. You've got your screen there, but they do it both physically and virtually, so that you run the virtual on Gazebo, and then you can bring up a physical robot that uses RViz for visualization. The difference between visualization and simulation is RViz ROS Visualizer versus Gazebo. Gazebo features physics, okay? But here they break it down with the computer. This would be the computer that's running on the robot, probably a Raspberry Pi. What's interesting is this EKG extended Kalman filter, so you could tweak things like odometry versus scan lines, stuff like that. They also use micro ROS running on a Teensy for the motor, the encoders, and the IMU. They have suggested hardware, all right, and they have a suggested motor driver. Oh, by the way, this is the ROS 2 version, Lino Robot 2. There is a ROS 1 version also. In the Lino Robot 2, it does differential drive, four-wheel skid driving, and Mechana drive. In the ROS 1 version, they have an Ackerman steering unit. Then these are the motor drivers, and then these are the IMUs it supports. And the cool thing is that it links up with those drivers and so forth in Gazebo also. So you can work in the virtual world as in the physical world. And if you've ever tried to understand Gazebo, well, let's just say there's no learning curve, it's a learning cliff, okay? So, and here's the Lino Robot project. They also support these different LiDAR scanners, including the Nito XV11. I've picked up one of these LD06s, but they got RP LiDAR, YD LiDAR. They've also got some 3D cameras here, but this is supported stuff in the Lino Robot project. And again, it's linked with the drivers and so forth in Gazebo. And so what I'd like to do at this point is just give you a little demo here. Let's see where I'm going with this. I'm going to minimize this window, and I want to minimize this window. And so these are the commands I've used basically in 5 different terminal windows. I've launched the ROS URDF, the Universal Robot Description Format. I've launched the Gazebo, which is the simulator. I've launched the RViz ROS Visualizer, which is the visualizer. Then I launched the teleop keyboard so I can control the robot with my keyboard. Then I launched Slam Toolbox. Then I launched the Nav2 stack, okay? And so just to see what that looks like, it goes something like this. So here is, okay, here's my teleop keyboard to drive the robot around. I always make it a special size so as I'm carouseling through keys, I can spot it. And then I put it in the regular place, lower right-hand corner. This terminal window is running the Nav2. This terminal window is running Slam Toolbox. This terminal window is running Gazebo. And this terminal window is running the URDF. I got started in this looking into the model editors in Gazebo and thinking, well, you don't want to know what I thought. Then I look in EasyCAD and OpenSCAD and those kinds of things, and it's pretty deep there. But I came back to the Gazebo model builders not being too bad. If you do URDFs, it's basically XML files. They don't look so bad after all either. But the point is here with the Lino robot, they've got some the URDF files are interchangeable, and it's a good way to learn it. A lot of this stuff, it's hard to find where the learning curve is. Let me go to my cheat sheet here. And so with the Lino robot project, you go to the URDF folder, and it looks something like this, okay, which defines the base width and length and the wheel radius and those sorts of things. And I basically plug this in to make the robot that they spun up in there's like 3.5-inch wheels with a 10-inch base. And so I basically changed the base and the wheel radius so that I had a 20-inch base. And I meant to do 5-inch wheels, but I put in the diameter instead of the radius. So now I have 10-inch wheels. But regardless, for this demo, I've gone back to the stock robot, which was smaller than I expected. But to the point, this is where you get into that scalability where you can really build the robot that you want and get into ROS and Gazebo and all that good stuff. So here I've launched the URDF, the Universal Robot Description Format. And here I've launched Gazebo. Okay, and This is the gazebo world they supply us with, okay? Here you can see the little robot, okay? The first time I launched this, I was like, I can't find the robot. It's down here. Again, it's like 3-inch wheels and a tennis chassis, but this is the caster wheels. This is the camera, and this is the LiDAR. I changed the frame to be 20 inches and the wheels to be 10 inches. And I flip-flop my LiDAR with my camera because I prefer the LiDAR low and the camera high. But again, it really gets you into the design of the robot, which is a very difficult thing to do. So there's gazebo. And again, there's the URDF. Here comes RViz. Is this RViz? Yes, RViz, the ROS visualizer. And it looks like something like this. I've been driving it around a bit. Okay, but it starts off not knowing anything, right? And you're mapping and you're scanning and those kinds of things. And again, what you're doing is you're mapping this gazebo world. And the point is you want to be able to navigate within it. That is, point and click somewhere within there and navigate. So the first thing, or the third thing, is SLAM Toolbox, which does the mapping. And then finally, the nav2 stack. Where is it? Let's see here. 1, 2, there it is. Okay, this is the this is the SLAM, and then this is the nav. This is the nav2, and then this is the teleop keyboard. And so let's bring up our ROS. This is the visualizer, and I can bring up my teleop keyboard and drive the robot around. You see it going forward, moving up on something. Let's go to gazebo. This is the world that you're mapping. And ideally, this would be a physical robot mapping a physical world, but here you're able to do everything virtually. And if I back up, you see the robots moving towards that, and that's what we're mapping. Let's see if we can do some navigation here. Basically, 2D goal pose, and I'll point, press, and drag right here, and mouse up, and we get a path planning line. The robot's turning, the robot's driving towards our goal. So this is autonomous navigation. Actually, I've done a lot of this, and usually I drive around, create the map, save the map. You may have heard me ask the question to Steve today, and then you navigate with the nav2 with nav2. If you leave the SLAM toolbox in there and it gets a lot misaligned, it'll screw up your map. So I get much better success in mapping, saving, and then navigating on a static map, given that your environment doesn't change too much. But with this, I've really gotten into what's called lifelong mapping. And here you just leave the mapping on, even as you navigate around. That way, as unknown territory becomes known, the robot can include it in the map and keep going. So here we go towards this corner here. We're easily amused, huh? But this, this is fun stuff. This is do with the Lino robot. Anybody interested in getting into ROS too? This is a good entry point. I maintain I'll put my GitHub here, where I have the Nito bot vac package. It's a ROS 2 package, and I think it's a really good way to get into ROS also. Let me get my GitHub page in here. Questions? Very fine.
All right. Thank you, Cam. That was
Thank
very
you.
interesting.
We had some fun.
Yeah, I have a question, Cam.
Shoot.
You've been pushing the bot back for a long time. How does this compare if you're first wanting to get your feet wet in ROS 2?
It's a great place to start. I mean, you want to do the nuts and bolts. You want to learn it all. But there's so much to learn that if you take that approach strictly, you'll never get to a moving robot. with the bot vac, there's a package out there. You can get the mapping and navigating right away. Then you can learn by deconstructing that, figuring out why it works. You know what I'm saying?
Yeah, yeah.
Yeah, this is Ross here with two S's. I can attest the bot vac thing. I was talked into doing that around a year or so ago. Got an old bot vac on YouTube and on eBay, and it worked really well. I got the darn thing going within a few days of pulling it out of the box. So it really is a good learning tool.
Yeah, if you look at the alternative, the TurtleBot 3, of course, is a forthcoming TurtleBot 4, but even that's built on an iRobot i3. The TurtleBot, which is the current standard, is a tabletop robot. So at least with the bot vac, you get a medium-sized robot. You're not on the table any longer.
Yeah, it's certainly a good starter to playing with it platform. I have a TurtleBot 3 too, as well. TurtleBot 3, which I've had for about 4 or 5 years now, and it still works really well. And you dig into more things with that, but certainly the bot vac is a great way to get started quickly on ROS 2.
And yeah, go ahead. I'm sorry.
I was just saying, I got a bot back a bit ago, and now I'm, learning ROS 2 as in earnest to get to use the bot back, but very inexpensive and way to get in. And
it's
like
hard. It's hard to give it up to cleaning the floor, right?
Mm-hmm.
Yeah.
Yeah, I keep mine on the charger just in case my wife wants some work done.
You have to buy 2, Jim.
I got
they're only 50 to, depending on which one you get, 50 to $100 depending on which one.
Yeah, under 100, like $80 or something like that.
No, thank you. So in the interest of time, I moved the camp over to do his show and tell, but now we can move on to the actual format of the business meeting.
Oh, okay. Oh, you would have him go first before business.
Ron, can you give us the treasury report?
The money from is being moved over to our account.
From PayPal?
Yeah, it's around $300 and some.
Okay. And
on top of the.
So what is our?
What's the balance?
Do you have our balance?
Near 1,000.
Near 1,000.
Because it was 300 and some expenses.
Yes. And that reminds me, so we now have the ability to pay our dues online. You can get the link on our webpage, right on the front page. Or if you're here in person, you can just talk to our treasurer, Ron. He'll be happy to take your money. So there isn't any extra benefits of becoming members other than that you can vote on elections and you can run for an office. Everything we do is free and open. You can attend our meetings as much as you want. You can participate as much as you want. There is no limit on how much you can attend or participate. The membership is solely so you can say that you're a paid member of the Robotic Society of Southern California and can vote. We usually blow all the money on our end of the year party anyways. It's not like if we're,
Well, don't say blow.
We don't blow. We have to be a little careful with that because we are a nonprofit organization.
We are a nonprofit organization.
And we have to maintain that properly.
Yes, so we, all of our funds, we utilize.
Yeah,
at the end of the year.
We have ongoing costs.
Like that $300 and some, we had our website.
Right, we do have bills.
And that was really, because we got that for 2 years. And then we also had our name,
The domain.
RSSC.org.
Yep. that's the name.
And that was around the same. So near that, and that was gee, started with a D or something like that. GoDaddy or,
GoDaddy, yeah.
yeah,
Yeah, but it adds up.
that was, it's good for 5 years now.
That's good for 5 years.
Okay, so.
So those are legitimate expenses there.
Yeah, so
Yeah.
we appreciate all donations for our expenses as well as for future events here, like pizza parties, if they should occur. You don't know yet.
Right, so for our next month's meeting, do we have a talk lined up, or Jim, are you gonna continue your talks on Orange?
I could, yes, I mean, I've been thinking about some topics that now I forget what it was, but yeah, I had a topic on well, I think it was building the follow me behavior and the tracking behavior, covering that more in detail and for a lecture.
That would be good.
Because there's a bunch of pieces to do that, to let it follow you. Basically, robot follows you. How does that work?
Right.
So I'm available for the, I guess, yeah.
Okay, and
next month.
Alan?
I'm always happy to talk about whatever I'm working on.
Okay, so we have 2 speakers for next month. But of course, if anybody would like to give a presentation on something they're working on, something they're passionate about, let us know and maybe we can schedule it in for a 1-hour presentation. Other than that, if you just have something quick and short that you're working on and you want to demo it, you can always do a show and tell, which we have at the end of our meetings. Those we ask to keep under 15 minutes. Now, Bob, you say you had a couple of business meeting topics you wanted to discuss?
Yeah, hello, everybody. My name is Bob Barbosa, and I'm a board member here with the Robotic Society of Southern California. I've been a member for about 8 years and took 2 years off for COVID. So I'm back today for the first time after the great COVID shutdown. But if you look on the website, you'll see by my name that I am also an advocate for high school and other kids participating in our club. And in that capacity, as a board member, looking over that population of kids, I was thinking about something. After hanging around here for 8 years and seeing the incredible projects over 8 years, that I was looking across the table and I see Brian over there. And I remember we had a contest called Around the Box. And Brian just quietly sat there and said, okay, I'm gonna go home, I'm gonna work on this Around the Box thing. And we put a box on the floor. He built a robot that went around that box and blew our minds. So I call that a mini Zoom. So think about that for a moment. That's one club member who did an incredible thing, and Brian must have done 20 things after that. But that really stuck out in my mind because it was short, it was sweet, it was powerful. I call that a mini Zoom. So in my capacity as an educator, I am working at the Ontario International Airport, and I have 60 students that are studying space and aviation. This is a program that we put together where those kids participate at no cost. I keep telling them about the Robotic Society of Southern California, and then it hit me. We are in the business of hybrid learning now, where I'm here in person and the rest of you out there in computer land. We could broadcast to my students, but we can't broadcast the regular program because I was sitting here today and I thought I was in a PhD robotics class. So of course, that would be a little difficult on my high school students, but at the same time, they need to be at the awareness level that we're doing stuff like that. So what I'm thinking of doing is piping this meeting into my class, because the reason I miss most of these classes is I'm down there teaching on Saturdays. And it just breaks my heart because I've been a member of this for 8 years and I can't even come to a meeting. But today was my day off and I'm here. So this business of the mini Zoom is something that I would like to promote, to see if I could go to each member of this room and say, is there a small little project that you could share with our kids? And I'll keep growing that group of 60. But a little something in somewhere in our club meeting where we could say, okay, let's have 3 of these mini Zooms. They're short, they're sweet, but they're powerful. So, and then we have $1,000 in the bank. And the youth portion of our club receives very little support. And it's, you know, nobody's fault. I mean, we're an adult organization. We never had a bunch of kids, you know, following us around. But remember at Christmas time when we were at the downtown public library and those Raptor robots came on the scene? Mattel was just developing them and we were just looking at those little Raptors. So guess what? Someone donated one of those little Raptor robots. So what I would like to do with these young kids is say, if you get involved in the mini Zoom, you're going to see what the adults are doing, and then you have an opportunity to do some mini Zooms that you could show to the club. Because the kids are working on some interesting things that would blow your mind in the robotic area. That might help us bridge the gap of the adults and the kids and bring us together. So I thought if that little Raptor robot, which I will donate, because I'm looking for a high motivational piece to get these kids excited. If I can get them to participate, if I can get you to participate, we might be able to close the gap. Okay, so that was my board report number 1. I got 2 more short ones. Before the great pandemic, we used to do a thing called the Robot Showcase, and we would go over to the VA hospital.
Oh, yeah.
And we would bring the best that we have or what we've been working on for the year. And we'd be just like this in a big, big circle, only that big, beautiful location right next door to the college. And we would invite the public in, and the public would come in and see what the Robotic Society of Southern California is all about. Well, now I have 2 incredible locations. I got a 50,000 square foot hangar at the Ontario International Airport. And I was thinking about doing a robotic showcase in June. But I changed my mind several times. And I said, oh, what a hassle. Oh, we're still wearing masks. We're doing this, we're doing that. So I kind of gave up on that idea. But I'm willing to revisit it because it's a lot of work and it's a lot of this and that. And you guys have got to step up with whatever you're working on because we need something to showcase. But what we can do is we can advertise and provide a free location. But that's in Ontario. And here we are, right here in Long Beach. We could go back to the VA hospital. We could always do that. But last week, our airport partnership expanded itself, and now we're at LAX. And the police department at LAX put up a big, brand new, beautiful building, mind-blowing building. Incredible location. And we're gonna do 3 Saturday events there. And I wanted to talk to them about the robot showcase, maybe in this area. Because it might be tough for you guys coming to meet me in Ontario. Except for Thomas there. We're closer to Thomas. But in any event, you know, things are getting better with the pandemic. We're starting to look again at meeting in public. What would you guys think if we brought back the robot showcase? We'd have to, you know, plan way in advance. But the whole idea is all of you are working, and the people out there in TV land, you're all working on incredible things. We could keep this hybrid approach where you could stay where you are and show your show and tell from where you are, and everybody here that's local could show up in person. So it's up to the club. You can vote. Should we continue that policy, or should we just drop it and move on, or do other things? You don't have to decide now. I'm just trying to put it on the agenda for next business meeting. Okay, the last item is this. There are some of the high school kids that are asking a lot of basic questions about robotics. In other words, the more I hang around down there, the more they fall in love with robots. And they're looking for some basic training. Now, Walter Martinez, one of our club members here, and officer of the board, we had the privilege of studying with the Parallax company for 1 week, or three or 4 days. So we studied with them. They introduced their robot. They wrote a beautiful manual and had lots of code that we could copy and download, you know, free of charge. So they provided us with beautiful documentation, lots of activities, and a free robot. So if we were Arduino guys, they would provide us everything on the Arduino side. If we were microbit guys, they would provide a similar situation with microbit. They gave us the robots for free. They trained us, and it was wonderful. It was absolutely wonderful. So that's another consideration for basic training for kids. But the kids are interested. I have the capability to transport this meeting into our environment if we just had a little section where we were kind of thinking of kids. Because if we did what we did today, it would be, they would think they're in their PhD program at USC in robotics, which is, you know, is terrific for us. But the younger generation, we need to reach out. Yes.
Have you heard of FIRST Robotics?
Yes.
Okay.
FIRST Robotics has come through here. We've had a chance to kind of see them. But these people meet every Saturday. Seeing FIRST Robotics is like Haley's Comet. It comes along every once in a while.
It's every year, and the competition happens usually in March, and you build the robot from January through February. So it's happening all the time.
So we could definitely include that. That's just another feather in our cap.
I don't think there's any teaching in FIRST, is there? I thought it's just, you gotta know it already.
No, the teaching happens through mentorship. So I did 8 years at FIRST. I was a high school student. I did FIRST for 4 years. And then as a college mentor, I did FIRST for 4 more years.
So
the teaching happens through mentorship.
So whoever's leading it will teach the kids.
Correct. And it could be parents, it could be, I did it as a college student. That's how our high school and college was set up. But yeah, it happens all through membership. So the students learn as part of building the robot. The emphasis with FIRST is that the students really are supposed to build the robots and do the programming of the robots. You know, various teams do a better or worse blend of mentor building versus student building, but that's the overall premise, that students build the robots and do all that. And there are several student competition teams in the area for FIRST Robotics.
1 year, everybody in FIRST Robotics showed up at the pyramid over here, and they took over the whole building. So we had a chance to kind of see that. I've got inner city kids in this population here, and it's a situation where you're a club member, you're here, you've been through their program. What could we do to reach out to the people in our area? So that's another good piece. So like I say, I'm on the youth side of the organization, and I'm looking for everything and everything to get our outreach, to reach out to younger kids. So with that, I conclude my report. If the club would like to see a photo essay of all of the work that we've done for the last 2 years with this space, aviation, and robotics program, I could prepare a photo essay and present it to all of you out there in TV land and everybody in here, if you think it's appropriate.
Why don't we maybe schedule you like not next month, but at the month for that for an entire hour, if you want to do something like that, because I know your presentations are somewhat lengthy.
Okay. Okay, then what I'll do is I will prepare something for that period of time, and then you could see what I'm talking about. Okay, thank you for the time.
Thank you, Bob. Is there any other questions or anything that you guys want to bring up in the business meeting?
Just one, maybe one final note. Thanks everyone for wearing your masks and the surveys and stuff. What's happening on the campus side is we're waiting to see what happens when our valued college students come back, how much of a spike we're going to see. And we are seeing a little bit of a spike. Over the next 2 weeks, we'll know if it's time to panic again or not.
I
But
have something to add to that.
okay.
When you're done.
Okay, so what we're hoping is the spike isn't that bad. And if that's the case, the campus is going to drop all mask and survey requirements across the entire campus. So I'll definitely post something to the forum as that progresses, but there is a chance that starting next month, we won't have to do all of this anymore. But we'll know over the next couple of weeks.
So here's what I have to add to that. My wife and I work for Honda Automotive. They're out in Torrance. They've shut down their campus mostly for the last 2 years, like a lot of places. We've all been working from home. Her boss called in the whole department starting, what was it, March 15th, full time, 5 days a week. Everybody's required to come back in the office. In the first 3 days, they had 3 people come down with COVID and cut it all back. So I don't know if that's a micro universe of what might happen.
Yeah, we'll find out together.
So now they're saying now they can come 2 days a week, their choice. And they have large teams missing because one person got sick and they had to quarantine the whole team.
Anything else? There's two books left, free, if anybody wants them, they're right here. Other than that, I guess we can move on to the rest of the show and tells. We did camp, we did Bob. Oh, was that your show and tell?
Yeah.
Okay, so we did Bob. Ross, you're up next.
Oh, okay. I guess everything's okay.
Yes.
Good. Well, first of all, I got to say, I appreciate the opportunity to call in. We don't have this sort of thing from where I am calling in from, which is up in the Toronto area. So I guess I make this an international group. Anyway, I've got a couple of things, actually both related to stuff that was covered already. My first thing is, I have a question about using, it's a question, not a show, but we'll see. It's using the Oak D Lite, which many of us, a few of us have. And I've just started to use it with what they call, with Luxonis calls the Depth AI ROS. They have a repository that's got all kinds of ROS2 scripts on it. I'm running it on a Raspberry Pi 4G, which fortunately I bought a year or so ago before the shutdown occurred, or the long deliveries occurred. And I'm planning to use it on a Linobot 2 that Camp showed earlier, or talked about earlier. I'm starting with the OAK-D part because the scripts that that designer has are only cover the usual suspects, the real sense and the ZD. And I have this, and it looks as if this actually might work. So I'm curious if anybody else is pursuing using the Lino, using the OAK-D Lite with ROS 2. I have to say I was successful in getting it to I installed the depth AI dependencies, which takes about a half an hour to all the compiles and whatnot that's required. I was able to, you have to load in a compiled OpenCV, which took about a half an hour. And then load in the source into the Colcon and compile that. And that took about 3 hours. But it all actually worked without errors. I mean, it installed without errors. However, I was only able to get one of many scripts to work. And I'm now corresponding with the Luxonis folks using their platform. And I keep getting comments back, oh, the code is a bit behind. We'll work on that tomorrow. So anyway, I'll just leave that question open. If anybody's pursuing anything using the Luxonis device on ROS2, I'd appreciate some kind of interaction.
So I used it in ROS 1, and I think I had to do custom stuff to make that work. I tried using it in ROS 2, compile errors and something, and I just didn't pursue it. So
yeah,
I think it was a bit rough describing.
I got the compile errors fixed relatively easily, actually. Maybe I'm using newer code than your experience. Anyway, it's certainly fun being on the bleeding edge, as they say.
So Ross, have you go ahead. I don't want to get ahead of your presentation.
No, I'm done. I'm done with this part before I get onto the nanosaur, but go ahead. Please.
Have you decided what you're going to use as your base for your Lino robot?
The Raspberry Pi 4B.
But I mean, wheels.
Oh, yes. Yeah. A differential 2-wheel drive with, right. It's about a foot wide, about 2 foot long. Okay. No, it's not that big.
Have you already picked out wheels?
Yes, I have fairly big. Oh, you know what they are? I'm using a disassembled bot vac.
You're using a bot vac wheel pod.
Yeah.
Okay, yeah. So you'll be using the encoder and so forth that's built into that.
I've had to fiddle with the encoders, but I've actually got that part working.
I'll be fascinated to follow your progress.
Sure. Okay. Okay. Can I move on to the star of what I would regard as the star of the show, which is my one of the 2 robots in my workshop that actually work. I think we all know what that means. Anyway, this is
a functioning robot.
Yeah, this is a nanosaur. It's actually running right now. The fan's running. So anyway, this lime green nanosaur was created by a very creative robot experimenter, Raffaele Bongi, of Italy and UK now, and he actually works for NVIDIA now. It's built on uses a 2G that's sitting there on top, which I again fortunately bought a couple of years ago and found something for it to do. Anyway, it uses a 3D printed chassis, as you can sort of see. There's a circuit board under here that connects to the GPIOs on top, batteries on the bottom, uses 3D printed rubber tracks. And you run it right now, it's like an RC car. However, let me just bring something up here. Let's see, this, right. So the designer, okay, so this, I didn't mention this, but this is ROS 2 running that normally requires Linux 20.04. The Jetson Nano, as many of you probably realize, only works with 18. So it actually, the stack, ROS 2 stack actually works inside a container that has the scripts that are required to run it. And the designer is really clever. He's managed to create management scripts that make the fact that it's inside a container virtually invisible, and you can work outside, change some code, run a command, and then it updates what's running inside the container. The designer is also adding, he's doing the work right now. In fact, I'm sort of a trial person for him. He's adding visual odometry to it. And then in this picture here, it shows a, what is that? I guess that's the Intel RealSense. But I know that the designer has an OAK-D like I do, and it's in the works to have that work in the code.
Is it the original OAK-D or is it an OAK-D Mini?
It's an OAK-D Lite.
Hmm.
So it does have depth capability. In fact, that's the code I was working on this yesterday afternoon, which was producing the longest string of errors I've ever run on something. But
That's saying something, Ross.
I guess so. And just I guess to show that this thing really does work. Let's do one more final thing here. Normally, the robot's actually running live, so I could probably do it live, but I won't dare.
Oh, come on, Ross.
Yeah, right. There. Ta-da! If nothing else, it's cute.
Oh, we chose the dinosaur.
Yeah. I have a collection of 2 and 3 foot high robot fans who just love doing this. So there we are. That's a nanosaur. Again, it's ROS 2 inside a container on the Jetson Nano with a camera on the front. So that's it. I hope that was interesting.
Thank you.
Is that a package designed by NVIDIA?
No. He works for NVIDIA, but
I see. So he made the nanosaur package basically uses a camera and the what do you know what ROS package it uses, or is the whole nanosaur thing a ROS package?
It's all ROS.
Okay.
The camera, I know what you're getting to. How does the camera work? Yeah, he wrote, it uses the NVIDIA camera firmware.
Yeah, and just so I'm clear on this, I'm sure you are, ROS 2 requires Ubuntu 20.04, and the NVIDIA Nano is limited to like 18.04, if I'm not mistaken.
Correct, right.
Okay, so the container containerizes the ROS 2 code, so it thinks it's running on Ubuntu 20.04?
No, it actually compiles it. There's actually a compiled ROS 2 Foxy that will run on the 18.04. But you don't know that because it's inside the container.
Okay, so this version of Foxy ROS 2 that runs on 18.04, is that generally available, or is that something that was done up for this?
No, well, actually, when you run the install scripts, 2 hours later, the compile's done and stored on your machine, so that when you run it again, it simply loads the container that already contains the binary code that runs on 18.04. Did that make any sense?
Yeah, believe it or not, it does. You know, I'm still wondering where it comes from, but that just doesn't matter.
It's compiled. It's actually he takes the source, the Foxy 2 source, and compiles it on board. Actually,
Okay, but is it compiled on 2004 or 1804?
No, it compiles it on 18.04.
Okay, it actually compiles on 1804 and works then, eh?
Yeah, that's
Apparently.
right.
Okay, I'm not
What do
surprised.
you know? Yeah, I know.
Wait a minute. I am surprised. And okay, so he may be doing some kind of bare metal installation, because if I go to 1804 and try to install Foxy ROS 2, it's going to go,
No. Oh, no, there's some, I guess the word is jiggery pokery going on.
I think there was some jiggery pokery going on.
There is, but it works fine. And I have to attest, it's remarkably invisible. You don't know that that's what it's actually going. And there's some cool scripts that he's designed so that if you SSH into the Nano, when you first SSH in, you're looking actually at, I'll put it this way, the 18.04 Linux, and then you run a little script, NanoSOR activate or run, and you get inside the container. It's actually a root user ID, and you're now you see the ROS stack, the NanoSOR _WS, and you can see all the ROS code.
Let me ask one more question and then I'll shut up. So to be clear, the NVIDIA Nano is actually running Ubuntu 1804, right?
Correct. It boots up, and it actually boots up 1804, correct.
And then this, if you will, this Nanosaurus thing is containerized so that you just launch it and it happens, right?
Correct.
Yeah, okay.
And it's, in fact, this is the only of a couple of robots that I built. This is the only one that you turn, that you flash the switch, you put it on the floor, flash the switch. A minute later, everything's working. You turn on your joystick, and you can hand it to your 6-year-old fan and have them do it. You don't actually need another laptop to get it going, which is really good. Really good. On the other hand, if you do, of course, you do need a desktop, and that's where you do your work from. Good. Anything else?
I think the key right there was to hand it to the 6-year-old, because they're an expert at those things.
Indeed, actually. I can only hope. That's right.
Thank you, Ross.
A pleasure. Yeah, again, I appreciate the opportunity to drop in.
All right, so next in the list is Jim, and after Jim is Roman.
Oh, okay. Yeah, so I wanted to, all right, let me share my screen here. A couple of things. So I've got Orange here, and I'll put in, let's see if I can.
Sorry, I don't understand. Orange, I hear enough for him.
He's listening. Let's see, switch to the front video. Oh. Okay, so I've been working for a while on speech recognition for Orange, and gone through various different platforms. The first was the Windows SAPI, which is on board, very old, dates back to XP, I think. It's still supported, and it has a basic ability to do offline speech recognition, and especially if you give it a grammar, a bunch of rules that specifies the patterns of the speech, the words and lists of words in a kind of a XML format that you're expecting. And with a robot like this, which has a list of mostly set commands, 50 or so commands, it's pretty useful. It works. However, that system is old and it doesn't do well with with a lot of different people. And so I also use the Google Cloud Speech, which works pretty well. So I have a toggle on my system to go from, or I've had this toggle for offline speech or online speech using Google Cloud. And it also supports Google Assistant. And even I bridge those, so you can ask if you're in offline speech recognition, you can say, hey, the name, ask Google some question, and then it will forward it and give you a response from the Google Assistant. But in any case, that has its own problems with I found out that it's very difficult in a lot of cases to connect to Wi-Fi, and the latency sending to, I don't know, my system isn't as good as a speaker that you can buy, a smart speaker off the shelf, like a Echo. There's latencies involved and all that. And so, the cloud speech is just not as good. It's accurate, but it has to take this audio file and send it up to the cloud. And anyway, so I really like offline speech. I could just unplug the internet and I don't have to worry. And so most recently I started using, okay, now I'll share the screen, this system called BOSS, which is, if I bring up the, where's the web page? So this VOSC system is an offline speech recognition, and it's has its origins in CALDI, the CALDI research, which is a very well-known research, as well as the CMU Sphinx, or CMU has the Pocket Sphinx, and the Sphinx project was a very important achievement in offline speech recognition, and then just language recognition, natural language understanding. So I started using this, and it works pretty well. What's cool about it, is it on the introduction? What's cool about it is it is a neural network based, and it has models that of varying sizes. So what's really cool is its small model is a 40 megabyte, and it's designed to work on Raspberry Pi and other small single board computers. And lightweight, wideband for Android, et cetera, et cetera. So that's the one you use. You can also use a big model for other applications, and you'll get, there's different advantages to the big models, of course, if you can fit them. But I'm only using the small model. And so recently I brought in the robot, and I had people talking to it, and I do this at home, and it will misunderstand you. And I'll show you that in a second, how it actually last night, I exposed the different probability, or essentially the different choices that the system is making between to determine what you said, and it will rank them. And so, but another advantage of this system, if you're getting the wrong results, there are ways you can actually change the model or augment it. The model, I mentioned this last time, but the CALDI model is used in VOS, has three different sources: dictionary, acoustic model, and language model. And with this small model, you can actually update the vocabulary at runtime. And I actually attempted this, and I hit a problem. I did this last night. And I just want to discuss with you, like, this part of the story of what I go through is the problems too. So let me skip this and go into now you'll see here, this is, is the actual robot I'm logged into. This is for Big Orange. And I'm going to show you this is the control panel, and you'll see what it last heard is coming up on this this line here. And you'll see that update occasionally. So it's looking at the code here. Let me get to the right page. So I made so I was getting problems where you give it you'll give it a command and it won't get it right. And so you create this, you create a grammar, and this is kind of what the grammar looks like. So I have to do this one. Or is it Control Plus, right? So if you can see there, this is a list of different commands. Sorry for this.
If you close your area.
Yeah, you don't have to see, but you can see the commands here. Phrases, and this will help by submitting these phrases. You're kind of helping the system. You're increasing the probability that these will be picked, essentially. Unfortunately, that led to a problem, and let me show you the actual problem or the running of the system. If I go to the this thing here, this is the actual. Well, there's an example there. You see how it says, well, let me give it a command so you can see, but this is what the format is. It'll show you alternatives. I tell it to do 3. Orange, load map my house number 2.
Okay, I will load map my house number 2.
Now you
Map
notice,
locations are loaded.
okay,
That
time it worked, but notice sometimes it will, the numbers there, 295, 294, barely different. And sometimes it'll say number TO instead of TWO, right? So this is a problem that there are words that sound alike, that have the same acoustic model, will be confused in the response. So I was hoping that this modification of the vocabulary using this live update, you pass the grammar to the system that according to their docs, it will increase the likelihood that correct phrases will be used or will be chosen, but that their numbers will go up. This time I didn't get it to fail for you, but trust me, it does. And but what happened was it created a smaller model or a smaller file that actually reduced the functionality a little bit, so that if you said like my name is Walter, for instance, it wouldn't know all those different, the commands that have a wild card at the end, like name, there's a million names. So I want the robot to understand my name is blank, whatever that is. Unfortunately, it kept saying my name is unknown. Because with my model in there, but with the original, the basic, the default model, it could understand Walter, Susan, and Jim, and et cetera, without those names, like without any grammar. But if I have a grammar, I would have to list all those names. Any case, so I've asked the creators of this of OSC to see if they can point me in the right direction where I can use the best of both worlds, my suggested phrases that are the vocabulary of the robot commands, plus the ability to handle all the name, all the general variable random type names and things that the default model handles. So that's where that is now. And this confidence thing is really cool to be able to see. So like, yeah, let me try one more. Here's another. Orange. Orange, set up. Orange, enable map updating. Orange, enable map updating.
Okay, I will enable map updating.
This is sometimes it gets that wrong, but you can see it would say nap as in take a nap. So it's kind of funny when it gets things wrong. But in any case, it seems to be working well right now. Opposite of a demo.
Isn't that just the way it goes though, Jim?
Yeah, I want it to fail.
You want to show a problem and it doesn't show itself. Intermittent problems are the worst.
So that's what I'm working on, and yeah, this VOS system is pretty good, and the API is pretty interesting that it has the ability to modify the model at runtime for the small model, as well as offline you can do a processing step. But again, it's giving me that issue where if I modify it, I lose some benefit, I lose some capabilities. And it does get more accurate for the robot commands that are fixed robot commands, but it's less accurate when you throw in a variable or like variable language that is, anyway. All right, is there any questions on that? I have a ROS2 thing I'm gonna throw out there as a demo, as a separate thing, just for like 1 minute. But any questions or comments, suggestions on this? I'm new to this VOS system in the CALD world, but it seems to be working much better than the Windows SAPI, and it doesn't require internet like a Google Cloud. So. And it's more responsive than Google Cloud. It's quick. It doesn't have to send anything upload and download.
You want to do your 2-minute demo now?
Yeah, the ROS or
the Roman is next, but if you want to,
yeah,
are you ready now?
Yeah, I'll just do that. So anyway, switching off this.
The calendar date that you wanted me to speak at.
Having trouble getting out of the. Okay, have to uncover stuff. So I've been trying to learn the ROS. I've been rapidly trying to learn ROS2. I took a course in ROS1. Now I'm going through all the examples, and I figured I should prepare to understand nav2 since we had our very very well respected speaker today. So I followed this nav2 tutorial here. Oops. And it's the getting started tutorial, and it gets you using the virtual simulator TurtleBot 3. You can bring up RViz and Gazebo, and you can activate nav2, and you can have a virtual robot, a virtual TurtleBot 2, do a simple navigation. And it's all with this one commit. It's all set up for you pretty easy to use after you've installed ROS and everything. Now, keep in mind, I'm using this is actually a Windows computer, as you can see. And just a little plug for what you can do with, even on Windows, you can install the Windows subsystem for Linux too, and install Ubuntu 2008 or 2004. And that's what I've done here. This is not a very powerful laptop, and it's like barely able to handle all this, but it does do it. So
Jim, is that a virtual window or a special package that runs?
This is
virtual machine.
Yeah, Windows subsystem for Linux 2 is a part of the Microsoft's. It's a lightweight virtual environment, a virtual system that you can install Linux kernels or Linux systems into. And so it's with Windows 11 that WSL2 exists.
Oh.
WSL1 was created several years ago, but it did not have these. WSL2 has the full GUI, X Windows and everything implemented, so you can bring up full GUI applications in Ubuntu, and it appears on the Windows desktop.
Mm-hmm.
So it's very convenient for people that work in Windows, and
that's actually a big deal.
So it's sort of like VMbox then. It's Microsoft's version of that then, I guess.
A VM, it's like a VirtualBox. Is that? I am not sure that I know what you're talking.
VMbox is provided free by Oracle, and it works.
Oh, okay, that's another one, right?
But yeah,
So,
thanks for the tip, because I actually my laptop is a Windows machine, and I have a bunch of virtuals on it to do my roboting with. So great tip.
I could show you. Yeah, sure. I'll show you here. We're looking at the RViz, and this is the map, and I'm going to place the robot where it is. First, you tell it initially where the robot is, and then it's running slow, so you can actually see the particles. Initially, it doesn't know where the robot is at all, and you give it that. Then the whole nav system is now activated, and you can see here these blue lines are the LiDAR of the device of the robot. This little dot here is the robot. And so now I can do what Camp has done a million times. You do nav2 goal, and you click drag, release, and so you can tell I want the robot to go here. And now you see this faint line here. It's plotted the course through the nav. And now it will start. It's really slow. It's going very slow, but the robot will make its way along this path to the end goal. And so you're seeing the cost maps here and all that. And yeah, it's running too slow, but so that's very similar to what Camp was showing. But I'm just showing that you can set this up, and as a ROS2 beginner, this is one of the things you'll try out is the nav2 system as you get into it. Yeah, I think I'm just really low on, I need gonna get a new machine at some point here.
Is there any of this connected to Orange? Is this all virtual?
No, so this is a complete virtual environment. So I'll be working on the Nito bot back that I got and trying to implement this in a real robot.
Orange isn't using.
Basically, the RViz is a the ARV is a visualization of the gazebo world.
Exactly, yeah. Anyway, but so you take my word for it, if this ran any faster, the robot will move along. That's my quick and dirty, quick ROS demo of where I'm in the tutorials. And I definitely recommend the tutorials are pretty well done, especially if you've had any ROS 1 experience. But if you haven't, they're still written fairly, I think, pretty well for beginners. All right, that's it. I'm going to stop sharing. And yeah, there's ROS and there's the orange. I will switch back here. So thank you.
Thank you, Jim.
Nice going.
Last but not least, Roman.
All right, so Roman, thank you for giving us a short talk at the last minute. I've got your webpage up if you want to draw it. I'll go and I'll share the screen and I'll swap seats with you.
This is Chrome.
Yes.
Great product.
Okay.
All right, yeah, sure. You asked me to quickly talk about this. Hi, I'm Roman. I'm one of the co-founders of Foxglove. So I wanted to come today. It's the first time coming to one of these meetings. Check it out, see what it's all about. I live in SoCal, just a bit south of here. At Foxglove, we very much believe in robotics, and one of the areas that we're aiming to kind of provide our contribution to robotics is in visualization and data management. One of our first products is this product called Foxglove Studio. It's both a desktop and web app. I'm just going to click through to the web app. So before I do that, you can see on the homepage kind of what we're going to get into. In some ways, it's like RViz and various RQT tools put all into one. So if you're coming from the ROS ecosystem, a few things should be familiar. I'm going to go through a few features of the product for folks that aren't familiar with it, and talk about that, and talk about how it helps robotics development, and then I can field questions if you're interested. I'm just going to click Explore Sample Data because that will bring up a sample data set that I can just talk through. But if you're coming from ROS, you can open connections to ROS 1, ROS 2 live robots. You can do ROS Bridge for those of you that know what that is. So there's different ways to connect to live robots. You can also open local files. So if you have .bag or .db3 recorded files locally, you can just open those right up. And if you do that, you'll have a playhead. You'll be able to scrub back and forth through that file and visualize the same stuff. So you'll see that in a moment here. So I'm just going to go ahead and click Explore Sample Data. The app is, like I said, basically an amalgamation of RViz and various visualization tools. You can arrange these panels however you want. Actually, it's helpful if I just maybe start with a blank layout. So you can make layouts yourself. So 3D panel layout is pretty common. So if you're coming from RViz, a lot of things will be familiar. I can just turn on some topics and start visualizing things. Sorry, I'm going to move some, I'm kind of blocked from seeing part of the app here. All right. So if you've got this, you can just basically play your file. So this is loading what effectively would be a bag file, right? So you can load that up. We can look around the scene. If you're a user of RViz, this is all going to be very familiar to you. You can pan around the scene. You can do whatever you want. But from there, you can also add all sorts of panels. So as I'm debugging what my robot did, maybe I need to plot some information, right? And so I'm going to plot, just to be amusing, I guess I'll plot the, what does this data have? Yeah, I guess I'll plot the ODOM position X. See if that's actually going to plot. It's not really that interesting, actually. So this is loading over a remote file, so that's why it's taking some time to load. If it was a local file, it'd be pretty instant. I guess the internet here is not so ideal. So you can arrange all these panels. So this is a plot panel, and as we play the data here, you can see that as we're looking at the scene, sorry, let me change this real quick. Understand, there we go. That's the odometry exposition. That's a little better. And so as we play the data, we can correlate, what's happening with the odometry exposition to the scene. And we can just basically debug our robot that way. And as I mentioned, there's lots of different panels. If you're coming from ROS, there's going to be equivalents for a lot of things. If you're used to ROS Topic Echo, well, this is basically ROS Topic Echo, right? You can just start to inspect individual messages in this tree form. And again, as you play back the data, they'll change. So this panel right here is like a ROS Topic Echo. This is a plot panel. There's image panel. There's all sorts of panels. If we bring up an image panel, we can also see the camera at the same time. Sorry, it's just trying to download some data over the network connection here. There we go. And yeah, again, if you're coming from ROS world, we work with ROS1, ROS2, ROS bag files. You can just load them up right away. If you're coming from not ROS world, we have different ways of getting data into the system. We have both WebSocket interfaces as well as a custom file format. You can just write your protobuf messages to and then load it up into Studio. The idea being that as you work on your robot, you have to kind of analyze what it did, whether it's live or after the fact, and figure out what you need to tweak, whether it's in your speech algorithms, your motion planning algorithms, any of those things. So this is a tool that for a lot of folks doing robotics, it's day-to-day workflow, this type of tool. So I'll take a pause there and answer any questions, I suppose, if there are any.
Sweet Jesus.
What's the website again?
It's called foxglove.dev is the name of the company. Yes, foxglove.dev. The name of the product, the visualization product, is Foxglove Studio. We also do a data product. The idea behind the data product is if you're working in a robotics team, there's a lot more collaboration aspects to it. Your robots collect data, whether they're in warehouses, whether they're driving around, whether they're arms in manufacturing. As they collect that data, we warehouse that data, and we provide ways for you to stream that data into Jupyter notebooks to do analysis on it after the fact, or back into a visualization tool like this. So you can basically stream that data and share those links to those streams across your team. So if you're working in a team setting, you can post these on Jira, GitHub Issues, or Slack, and other team members can bring up the exact same view, panels, and everything that you use to identify a particular issue. So that's kind of how the whole data platform and visualization will come together. But the visualization tool is fully open source. Foxglove Studio is open source, it's cross-platform and web-based. So you can use it in Chrome on any platform, or you can download the desktop app on Mac, Linux, and Windows. And you'll use the desktop app if you want to establish a native connection to ROS1 or ROS2, because that requires TCP and UDP. If you're happy to use things like ROS Bridge or want to load local files from recordings, you can use the web app and that will work just fine.
Okay, good. And does it, you said that saves the entire layouts, and you can share that layout in some sort of preference file?
Yes, so there we have the notion of layouts here, and you can basically, you can make all these layouts, and if you're just, what we call single player mode, you can just make these all locally yourself. And then I believe we have a export feature where you can export this, and it's basically just going to save it into a file that you could load again. If you do make an account, we will synchronize those across. So if you use multiple devices or work on a team, if you make an account, we will synchronize those and you can share layouts with your team members. Yeah. So the free version, no account sign in, no, web required. You can just use it. You can make these layouts. Here's one layout where I have the topics, effectively the data source and topic types for those familiar with ROS. And then that's the exact same data I'm looking at here. And then I can just very quickly switch back and look at my images again, or, go back to this layout, which is one of our pre-made layouts, looking at this data set where you can see the 3D scene. I can come over here to maybe I'm a controls engineer, so I need to look at a bunch of graphs. Sorry, again, the data has to load over the internet. So it takes a moment for it to fetch the ROS-bag data. But here it's just loading up a bunch of graphs. Maybe I'm a control engineer and I care about, speeds and values. And as I play this data, I can just compare and correlate. Similarly, if I want to look at diagnostics data, I can just switch over. So there's all these layouts and tabs, and you can organize this however you want. Yeah.
Wow, there's a lot of UI.
Yeah. There's also, you can write little scripts to transform messages inside of Studio as well, but I'm not going to bother showing that right now.
Where is it, like that 3D window, is that typically, how is that data coming or stored? Is that captured by the, you know, the device or the, like from multiple channels of data? And,
yeah, it's just the same thing RBIS does, right? So here are topics.
Okay.
So these are your ROS topics. So you have map, which is a nav message occupancy grid. So the 3D panel that we have, it understands these what we call well-known message types from ROS, just like RBIS does. So if you come to us with a point cloud or a occupancy grid, we visualize that. So let me turn on, LiDAR, which happens to be a, sensor message point cloud 2. So we understand that, and we can just visualize that, just like RBIS, right? It has a notion of these various, sorry, I don't normally use a mouse, so it's taking me a moment to get used to how to navigate this.
How do you normally navigate?
I use a trackpad on my laptop, and I have a standalone trackpad, So I use a Mac laptop for all of my developments, and I use the trackpad and standalone trackpads. But because this tool is cross-platform, I can do my robotics work in maybe a Docker container or Ubuntu machine, and then, review my files still on my desktop app. Yeah, so this is just playing through. And like I said, if you're coming with a recorded file, you can just seek wherever you want in the file. Which is somewhat tricky to do if you're just doing a ROS bag replay in ROS. Sometimes a little challenging to get to a particular point in time, but if you load a bag file, you can just seek wherever you want in that file and scrub through the data and really figure out, what went wrong at this particular time. I think maybe I have some like diagnostics messages I could look at. Yeah, we have a different panel, better panel for diagnostics, but you could do this if you wanted to. Look at diagnostics messages in this way.
Is the geometry of those other vehicles, is that also a ROS?
Yeah, so ROS has this concept called markers.
Markers,
And so there's a visualization message marker array. Again, RBIS supports this as well.
Yeah.
So yeah, you basically publish these markers. I'll show you what they look like. The raw message panel is very much like ROS Topic Echo. It's great for learning what's inside of messages. So you can see in the markers annotations, we have, this one happens to be a type 1, which I forget, it means something specific in RBIS land, probably a box or something. And then there's various coordinates of the box. Maybe it's text. There's some text. Maybe there's some text. I don't remember. Yeah, I mean, there's some documentation in ROS around what markers are. And we're also documenting our own versions of these. So if you don't use ROS and you use like systems with protobuf or something else, we have versions that you can just, if you match this message type, it'll also display and visualize. So again, the idea for us, we're framework agnostic. So we want to support any sort of robotics development. But we started as supporting ROS out of the box, for sure.
It looks like this, even for, someone who's, once you've been through the basic tutorials and you're doing all that command line and looking at messages on a terminal window, eventually you upgrade to this, to this tool, so you can, it's almost like an advanced IDE for that is far beyond, that can show you the ROS topics and things, all of this stuff in a much more centralized and easy to see than doing with multiple shells and RViz. And RViz is so much more sophisticated, right? It seems.
Yeah, there's definitely trade-offs. We view this as your debugging, diagnostics, and visualization workflow. So we want to make it much easier. So you don't have to launch a bunch of RViz and RPG windows. You can just do all that in one place. You're still probably going to be launching shells to do your ROS launch or your work for sure. We don't have just terminals in here, not like VS Code does, for example. But we do want to simplify the process of debugging, diagnosing that data. Absolutely.
Or learning as well. You can bring up RQT windows in there and show the bubbles and everything connected and as well. That sounds like this is something that even a beginner should might want to try using.
Oh, yeah, I guess if you want to look at it, Ross taught, it's a little tricky to look at this system. I don't know exactly, this is like what topics there are, but this is a weird data set to look at.
Oh, that's probably a more,
Yeah, it's not well organized, but if you had a
Simple
little
one.
more sensible robot, this topic graph would tell you what nodes and topics and publishers you have. I think these are all just like kind of poorly organized because it's a little hard to, it's all just like made up data. So this sample data set that I'm looking at here, we generated from New Scenes, which is a public open source data set. So we generated this data set from that. But if you have a real robot, the graphs and things will look a little more sensible.
Is there a hobbyist version of it? That's free?
It is free. It is completely free. There is no distinction for hobbyists and non-hobbyists. You can download it for any, you can go to the website and just use it from the web version, or you can download it, and you can also find the source code on GitHub. I don't know why we don't have a link from here. We have documentation around how to use the different types of panels and what the panels do, how to do your own messages, other various app concepts. But yeah, the source code is.
Is there a Mac version of it?
Yes.
Mac M1?
Yes.
Good.
Yes, we have ARM builds of Windows, Linux, and Mac, and we have Intel builds of Windows, Linux, and Mac. So yeah, the source code's all here. We work pretty in the open. We welcome all contributors and issues, and we also have a Slack in the README. You can, I think we have oh yeah, we have somewhere we mentioned our Slack group somewhere. Yeah, you can join our Slack, and we're always happy to answer questions. Yeah, but we have versions for Mac, Windows, and Linux for both ARM and x64, I should say. So yeah.
But did you, were you part of the, it says here that you guys worked at Cruise.
Yes, I worked at Cruise.
Did you notice there was Charles Knowlton was here, a friend of mine. He worked for Cruise for like 2 or 3 years, 3 years. He was over there, but I don't know if you, I don't know when you, that might have been, might not overlap, but yeah, it's, so some of the brains of the operation came from Cruise, and Cruise has been developing for several years, doing yeah, I mean, doing the autonomous driving and all autonomous vehicle research. So that fit perfectly into this is a perfect product for them to use as well.
Yeah, the early versions of the studio were built off of this product called WebViz, which we open sourced from Cruise. But yes, we've been working on this problem for a long time. But the tool itself is applicable. So part of the vision of Foxglove is to apply this tool to more broadly than just autonomous vehicles. And we have users across the entire robotic space, from manufacturing, from underwater robotics, all sorts of interesting types of companies and users. Yeah, but yeah, it's a completely free tool. Studio is a completely free tool. You don't have to make an account or anything. Welcome to try the web or download the desktop app.
So let's talk maybe Ross politics for a little bit. And I'm going to start off by not talking about RSSC. The last, we're going to get back to that. The time before last one, came back into ROS 2, I was looking at the simulation tools. And, you know, Gazebo is based off of Ogre, which was great in the 1990s. And it's still the de facto standard for ROS and ROS 2 simulation. And then there's a couple of other like new entries. There's some Unity integration, whether you consider that fracturing or the future. But what really knocked my socks off was NVIDIA Omniverse. Like just the approach and the imports and the modular and like everything looks to me like it should be the future of ROS simulation. And I get this same vibe, to come back to Foxglove, I get this same vibe from Foxglove. RViz, great in the 1990s when it was first come out, it still serves its purpose as a data visualizer. But, and not to slap you on the back too hard, but this looks like the future or the next version. Any talk about supplanting the old standard? Are there features missing? in CSULB that are still present in RViz? Because this looks to me like a total open source, multi-platform replacement that does everything well that RViz does poorly.
There are a few so the things that RViz still has that we don't really have, like great answers for you. There's still probably a number of message types that RViz supports that we probably just don't have support for. We could build, but they just don't exist today. So there's like some visualizations. And then there's a number of teams that have built RViz plugins to kind of further enhance RViz. So I know things like Move It and that framework. Those folks have built a few RViz plugins to kind of help folks work with their tool sets. We have the notion of extensions where you can build your own panels, and we plan to add more extensibilities in the app to kind of fill that niche. But we're still, trying to get the word out there and help folks with that. But yeah, so those are the two big areas that I think if you're using a platform like Move It, and you really need some RViz plugin that they give you, then obviously you're going to be having a trickier time moving off that. But if you're just using RViz to visualize a 3D scene with a bunch of stock messages, you're going to be able to use Studio no problem for sure. And our hope is to, continue to grow that feature set so that you don't have to effectively turn to RViz, which I think is it's not getting as much active development these days as it used to. And it's really focused around the 3D scene, and doesn't try and do these like collaborative features or anything of that sort.
So what it's focused on what scene?
Is focused much more around a 3D scene.
3D,
You can bring in like image panels in RViz, but that's about it. I don't think I've ever seen anyone really bring a plot panel into RViz or anything of that sort.
Just like the camera, you can bring a camera view and things like that. But yeah, man, RViz is long in the tooth.
Yeah, I mean, there's some development that goes into it, but not a lot of active development. And so that is very trade-offs. RViz has done wonders and it's been around a while. It's a critical tool. Like we view these visualization tools as very important for iterating on robotics development. And so, yeah.
Hey, it works okay for, for a hobby use. I've got this little model and RViz can really, it's not challenged by the data or anything, but if you start getting more and more data and you want to visualize it all easily, you need more sophisticated tools, I think. I mean, certainly the professionals do.
Yeah.
This is very cool. Thank you for taking the time to show this.
Yeah,
We've got more than a couple of converts in the room.
Yeah, you're right.
I'm gonna be down.
Very cool. Very cool.
All right, does anybody else have anything to add or ask, online or in person? If not, we will wrap up this meeting of the Robotics Society of Southern California. And again, next month, on the second Saturday of the month, which will be just May 14th.
Yeah, 14th.
Yep. So May 14th, again, both in person and streaming live on Zoom. Hope to see you guys there.